Okay, let's start. Good morning, everyone. Welcome to the final conference of Level Up. Thank you for joining us here physically at Brussels and also remotely. We are going to start now. Yeah, the agenda, I think we will have a lot of interesting talks related to the level of results, the achievements we achieved so far, and some insights what that we have learned through this project. So we will start with some presentations from the partners, technical partners from the project, and then we have some success stories from the pilot lines who were involved in the project and who have achieved some results. And then after we'll have a lunch break at 12:30. It will be a good one for networking and so on. And then at 2 o'clock, we will have a panel discussion moderated by Dimitris. And then finally at around 2:40, we will have the level of a general overview of the project by the project coordinator, Roy Mendes, and we will close 3, hopefully. Okay, so I will right away start the presentations. So I will invite Andreas. Andreas is a committee manager at Austrian Standards. He studied mechatronics and robotics and was also a CAD designer at some point. He worked in the fields of mechanical engineering before he became committee manager at Austrian Standards. So in the field of good knowledge in the field of mechanical engineering and circular economy certifications. He's managing different national committees. Please.
So hello and good morning from my side. Okay, as I've seen, the introduction has been done. Just a moment, can I also see the presentation on the screen? Okay, thank you very much. Okay, yes, hello and warm welcome to the first presentation for today's panel conference. Yes, my name is Andreas Becker from Austrian Standards International. Today I'm going to talk about what is circular economy in the field of industrial equipment and what does the topic of standardization has to do with a circular economy. For the most people, circular economy is the whole life cycle of a product. Just expect as an example of the glass bottle in front of you. A product is going to be produced, something is going to happen, it's been filled up with water, it's been sold, and in the end, it's going to be recycled, and hopefully a new glass bottle will be made out of it. But in the topic of large industrial equipment, it isn't often such easy to declare what circular economy or the whole life cycle of such a product is. And herefore, BIBA has declared 10 different protocols to ensure the standardized and formalized selection of these processes. These protocols can be seen in the deliverable 1.5 by BIBA on the Level Up homepage. These 10 protocols, herefore, it's possible to say how do standards and also regulations support these 10 protocols. As an example, here for protocol set, that modernizes the connecting the physical with the digital world. You can use the EN ISO 13849 part 1 and 2, which is part of the safety of the machinery, and it's about the safety related part of the control system. For the protocol 1 is the functional diagnosis. Mainly it's about the functional diagnosis of the machines. You can use as an example the IEC 62741, which is about engineering and data exchange for the format for use in industrial automation systems. For protocol 2, inspection, visual inspection of the machines, as an example, the EN ISO 3854, which is also on the part safety of the machinery and which describes the minimum gaps to avoid crushing of parts of the human body. For protocol 3, repair, deploying remain the actions, the IEC 6812. Protocol 4, disassembly, identification of failed components and any degradations. As an example, ISO 23247, part 1. This is about digital twin framework and manufacturing. Protocol 5, the upgrade protocol, replacing old parts with improved versions, EN 60204 part 1. Protocol 6, refurbishment, and Protocol 7, which have the same main part. This is restoring the system onto its original functionality. Protocol 6 are standard common ways, and Protocol 7 remanufacturing is to use additive manufacturing as one of its main parts. And here we have, for examples, for Protocol 6, the EN 15341, which is about maintenance key performance, or for Protocol 7, the ISO 10303 part 242, which is about managed model-based 3D engineering. Sorry. Protocol 8, recycling, is the process to reverse supply chain methodology. Here we have a main important part. This is the directive for the European Commission 2008-98, also called the Waste Directive. And for Protocol Omega, reassembly and testing, we have the EN ISO 12100, that most of the common ways for the risk assessment and risk reduction. So now, how did we done that to find the mainly important parts for the Level Up project? For the consortium partners, at first, we've sent out a survey on standardization and regulations. All the partners in the project has filled out this survey, and after that, Austrian standards consolidated these European and international standards, which leads us to a list of standards. And this list also leads us to our deliverable 8.7. After that, we have done a gap analysis, and currently it seems that there are no gaps for the consortium or for the Level Up partners between the industrial needs and the currently existing standards. Also here I have a short excerpt from a list of standards in our deliverable. These are the standards. This is just an excerpt of the standards which are used and triggered in the Level Up project. And maybe, as you can see, there are a lot of standards in the field of safety of machinery, but also standards about test codes and machine tools. And additionally, there are some special standards about maybe hydraulic fluid power or welding or geometrical product specification. So now it's red. And then bringing this standardization from the Level Up protocols to a next level, we have started a Senelec workshop on the Level Up. At this workshop, the kickoff meeting has started. The kickoff meeting was in December 2022, last year. Yeah, actually the working draft is already finished. The last meeting has taken place, I think, in August, 2 months ago, the beginning of August. Yeah, and the next action is to announce the last meeting, next meeting and the last meeting for this workshop, and then the publication of the CWA. As an additional benefit, the CWA will be able to download at the homepage under the prepayment policy of Senelec. The following homepage, I think you will get the presentation. And it's not necessary to note the link. So then, thank you for your attention. In this way, do you have maybe any questions? You can
Yes, I forgot to inform, but yeah, let's make this more interactive. So please raise your hands who are physically here if there are any questions now or at the end of the session. And the participants remotely, you can type in your questions. So we'll have a look at the questions and ask them. Okay, maybe I have one question. Maybe it's very general. So on one side, you have the standards, and on the sides, the industry that has to or needs to adapt these standards. So what are the challenges for the industry to adapt to these standards?
The challenges mostly in the technical way, I think, because it's not often very easy to adapt all the workness in the standards to the product or to the machine or the production of the machine for its product. Not very easy sometimes.
Yes.
It's also mainly standards mainly standards are made from the partners from the industrial partners. So in the technical committees, these different technical committees, people from different companies are there to declare what is really necessary for a standard, and it's not made by some politicians or something like this. These are the directives. Yes.
Thank you. More questions? Okay, maybe we'll have during this.
This is no question.
Okay. Thank you, Andres. Thank you so much.
Thank you very much.
Okay, next we have Stefano from Podonix. He's an engineering technical manager. He holds an MSc in industrial engineering and has good knowledge and deep knowledge on IoT technology stack. He also has experience as a researcher working in mathematical modeling, simulation, and data. So please, Stefano.
So good morning, all, and thanks, Asif, for your introduction. And here today, I would like to speak about modernization of legacy equipment and machinery. And this is the agenda for today. So just a brief introduction to the context, the challenges, the aim and the industrial needs that drive towards this work, the methodology and the tools that we are proposing, and some real applications that are coming from our project. About the constant, you know that there is a digitalization process that is very is ongoing and that has an high impact on the real world, in particular on the manufacturing sector and the various sectors. And considering this digitalization process, there is also the tentative to join the part of digital and virtual with the real world. And so there is the evolution of the cyber physical system, and considering this evolution together with the evolution at the technological level of the machinery, we are speaking about modernization, not only in terms of technology of the machinery and the equipment, but also in terms of digitalization. Here the rule of the IoT, and in particular the industrial IoT, with the introduction of the interconnection with the protocols with specific device that allow to interconnect the machinery with the cloud, the field with the cloud, and in order to create added value to the data that is possible to collect from the fields, that try to perform a diagnostic and prognostic action on the machinery. So about the challenges, we know that the machineries and the equipment is very various. We have a wide range of machinery, both in terms of technologies, interfaces that are exposed, communication protocols, and so there are also, for instance, different PLC to control the equipment, and there is a question of the possible incompatibility of the assets with the new sensor that should be installed in order to modernize the machine, in order to create this digitalization of the machine. There is a difficulty in accessing data and collecting the data, and in general, there is the problem of evaluating of the cost of implementing this modernization action on the equipment respect to the purchase of a new equipment on that can be considered already digital. Of course, the problem of interoperability, considering the different protocols, different data format. So there is also a work that has been done as we have to do in terms of create some standards for enabling this type of interoperability. Obviously, in particular, also in the SME, we have a general resistance to the change. Sometimes it is also a cultural issue, and we have integration problems considering the different interfaces, the different data format, so both in terms of data integration and also application integration. And in particular, we are not speaking only in terms of revamping or refurbishment of a machine, because we know the retrofitting of a machine is not a new thing, but I think that the real new things is to add the part of digitalization to transform the machine into a cyber physical system that can be connected and interconnected with the cloud and with the other devices. So going to the aims, the main aim, that is the whole aim of the Level Up project, is to extend the lifetime of the large industrial equipment, in this case by modernizing the equipment. We have started by analyzing the end user requirement. So basically in Level Up we have 7 use cases that we will focus on during this workshop. And starting from the use case, we have tried to identify some goals that are common not only to the modernization issue, but also to the providing of diagnostic, prognostic, maintenance, and so on. So in particular, the goal of increasing the performance, increasing the quality, the maximization of the production rate, so improve the production time, the tentative to minimize the operating cost, and to have the tentative to have high reliability in the equipment, and of course the extension of the remaining life, the useful life of the equipment. Starting from this, we have tried to identify what are the main aspects where the modernization can have an impact. And so in particular, we are speaking about interconnection, so transform the machine and transform the equipment in smart equipment, the performing of data collection and data exchange between different modules with the cloud, with the software layer, and try to create a digital equipment, digital machines. And there is the aim to enable the remote management of the machinery and the equipment that are on the field, and the enabling the data-driven diagnostics and prognostics. And here, as introduced in the speech before, in Level Up we are proposing 10 protocols that are aiming at improving operation, the redesign and the design, improving the maintenance, creating new procedures, and in general to extend the operating life of large industrial equipment. These protocols are interconnected each other, so basically we can see that starting from one protocol we can also apply another one. So while you have to modernize the machine, you have also to upgrade it. You can also think to reassembly something, or of course the phase of testing. But in particular, in my presentation, I would like to focus on the protocol of modernization that we call the protocol Z. Here we have an image that tries to synthesize the approach that we have adopted, starting from an investigation of the machinery of the shop floor. And at first tentative, I integrated some devices, digital devices, cyber physical system, and the possible installation of a new sensorized device, and the installation of some IoT gateways that allow the communication towards between the fields and the cloud or the edge, so with the intelligent part of the system. Of course, there is also the issue of creating some interfaces towards the management system, so the MES, the ERP software for the management of the production, and the connections with more aggregation of data. So there are different data sources considering the equipment and the shop floor. And the idea is to aggregate the data in order to extract added value and obtain some prognostics on the equipment. And then the evaluation of the possible installation of new hardware in order to host edge and fog computing application. This is a circular protocol, so we can perform this protocol more times. And this is the general view. And in Level Up, we have tried to formalize this protocol considering some flows diagram and some sheets that can drive the user, the designer, or the engineer to adopt all the steps of this protocol in order to perform the correct modernization of the equipment that is an object of evaluation. In particular, we can identify 3 phases. The first phase is the integration of a manufacturing operation system. So in some cases, in particular the large companies has this manufacturing operation system that can manage not only the devices and the data collection, but also the management of the maintenance, the production, the scheduling of the production. So the idea is to evaluate if there is the possibility to adopt this whole solution, considering the shop floor. And then after this, there is the part of shop floor integration that is that concern more the part of new sensor, new devices, try to create a cyber physical system at the shop floor level, and then a part of the middleware. So leveraging the new devices, new sensor, but also the existing sensors that are present into the field, we can have a layer of interconnection and data management that can extract the data, that can collect the data from the field and make them available to other applications that can be related to maintenance or prognostics or other aims. And these are further applications will provide the level of analysis, the level of the added value respect to the data that we are collecting. In particular, here I would like to focus on the part of a shop floor integration that, as I said, it is mainly composed of 3 layers: the layer of the sensor, the layer of the cyber physical system in terms of adding a virtual part to the physical devices, and a part of a gateway that allow the communication a delegated communication from the fields at the cloud. From one side, the gateways is going to expose a very wide range of protocols in order to have the interconnection with the different machines and the different devices. And from the other side, we have created a standard protocols that should allow the communication toward the upper layer, that in this case is the middleware that I mentioned before. The middleware has two main aims: the data integration, so the collection of the data considering a certain format and schema, but also the data interoperability in terms of semantics. Going on the first part, so we have provided a middleware for data integration that lays a foundation of microservice-based architecture that provides firstly a data collection layer towards the fields through some M2M protocols, particularly MQTT. And we are providing some edge-based process facilities for re-elaboration of the data, and a data streaming platform and cluster to support reactive data processing and application integration. And so in this case, we are speaking about event broker, such as Kafka, for the integration on the upper layer. We are providing also capability in terms of a long-term time-based data storage that is delegated to another component that is a knowledge-based system. And we are ensuring a correct level of security by addressing authentication and authorization issue, considering the new protocols that are available, so OAuth protocols and open source component such as a Keycloak, so very well-known component that can assure security. And then there is also a part of data interoperability and annotation of the data that is delegated to another component that I'm going to introduce, that is the semantic mediator. So we are acting in mediation for data interoperability. We are starting from the pilots, from the shop floor. The data are published on the middleware, considering some standard format, so JSON or XML or GSV, so very standard formats. And here we have the data integration part. Then we have the tool of the semantic mediator that can extract the data from the Kafka cluster, so from the data streaming platform in real time. And the semantic mediator is applying some mapping rules in order to transform the object from some standard data object to ontology object. We have an ontology that is representing the full domain. And so in this way, we have a data transformation that can create some semantic annotated data that can be very useful in terms of interoperability, in terms of extract value from the information that we are gathering from the fields. And then there is the part of storing this information into a triple store, considering the standard, the format of the ontology, and the storing of the information into the knowledge-based system that is a long-term data storage for time series data that can host data into JSON format. Here, I'm going to present you some application inside the project. So we can consider the Isocon pilot line. Isocon is a Slovenian company that has a production that is based on basically extrusion processes. And so in this case, we are considering an extrusion production line that has been created about 15 years old. And it is subjected to a small regular maintenance work. We are considering the extrusion of plastic profiles for caravan industry. And this production line is equipped by an old control system. the starting condition, we have a very limited possibility to monitor the machine status, a lower level of productivity, the presence of failures, and a maintenance that was based on just a predetermined intervention with no predictive or no other type of maintenance. So we have applied the protocol about the modernization. And so we can see the application in the first part that is related to the field, to the working cell factory, and to the enterprise, so the part of devices, sensor, and so on. And here I have listed the intervention that we made in terms of sensorization with new sensor or improving existing one, and with the creation of a cyber physical system through the deployment of a PCUA server, and the use of a gateway for the interconnection between the sensor and the upper layers of the system. Instead, modernization and the level of middleware is regarding the part of the Kafka middleware. So it is a point of the integration between the gateway that is provided by SenseApp and the other modules for the diagnostics, and the middleware distributes the real-time sensor data that are gathered from the field and exposes streaming information to the predictive maintenance model, to the FMECA, to the TSS that are going to perform the expected elaboration. And here just some indication about the data that we have gathered from the fields and the creation of some data schema in order to formalize the information that we are gathering from the fields. And here there is the part of the semantic mediator activities. So in particular, we have started from some JSON format input that is the format of the data that are collected into the middleware, and then considering the method that I have exposed before, we have applied some mapping rule in order to transform the data in some ontological object that can incorporate the semantic and can allow further activity in terms of inference of the information, applying some rule engine in order to create some rule-based maintenance activities or other application. So this is all from my side. Thank you.
Questions from here? Yes,
Yes, I want to make a question to you, Stefano. I'm Dimitris from Core. We all know the basic huge advantages of moving to Industry 4.0, especially the data-driven and sensorization and optimization of the factory line. But as I know, you have a huge experience on modernization of all machines. And I wanted to tell you if you have noticed any disadvantage to moving to Industry 4.0 standards in comparison to the old PLC machines in the old industry. And if there aren't any disadvantages, what are the main challenges for this movement towards a new era?
Okay. I think that it is not really correct to speak of disadvantages, but we can have some inconvenience. In particular, in the small medium enterprise, you know that there is a resistance also at the cultural level in order respect to the innovation process in general. So I think that if the innovation will be too complex, we will not obtain good results because the innovation cannot be understood by the person. So the suggestion is to go in step by step to produce training, to produce dissemination activities in relation to digital innovation, to the digital processes, to the CPS. So the cloud should not be a problem. There are no security or cyber security issues that cannot be addressed because we have the tools. So I think that the first step is to create a sort of promoting and dissemination aspect respect to the digitalization and modernization. Then, of course, we have a wide range of opportunity for a digitalization of the equipment, starting from some basic solution, more complex one, MOS, so manufacturing operation system that can cover all the life cycle of the machine, but also some basic, some sensorization that can allow particular operational activities, a maintenance of a component that was critical before. So this is my perception about your question.
Thank you very much for your answer.
Okay, thank you. Thank you, Stefano. Okay, now this is from Atlantis. He's a project manager at Atlantis. He holds a master's degree in nanotechnology and experience working in renewable energy sources. He has experience in process optimization and project implementation as well. So he has been very active collaborating with cross-functional teams and stakeholders and to drive innovation. So this is.
Hello everyone, thank you for the introduction. Well, today I'm going to say a few words about predictive maintenance to you. So the content of the presentation is structured in a few sections, from what is the predictive maintenance, what is the challenges and the aim of the industrial needs. These are quite similar to Stefano, so I'm going to fast forward them. What is the methodology that applied in Level Up? And I say a few words about the tools, the predictive tools developed in Level Up and the results, as well as I will mention some main barriers to implementing predictive maintenance. So what is predictive maintenance? Predictive maintenance is a maintenance strategy quite different from the rest of the strategies that already exist. It applies real-time condition monitoring to receive real-time data, as well as uses historical data to feed advanced modeling techniques and models derived from artificial intelligence and machine learning in order to predict failures before it happens. The idea is to allow the businesses to anticipate failures before they happen and schedule maintenance without the risk of breakdowns. So they can reach their peak performance and their maximum potentiality. So moving on to the challenges. So we have identified a few challenges. The first one is the data quality. In order for the predictive maintenance to give accurate results, we have to have high quality data to support high accuracy. So also, but in order to receive this data, we have to collect them first. But this can be a problem combining with old legacy equipment. Also, the data should be accessible and portable across different processes and systems, as well as these different systems and software should be able to integrate together to give a flow. This comes together with incompatibility issues. If you have old legacy equipment, it can be difficult to connect them with new sensors, new interfaces, or new software. And of course, the challenge is the cost. This may not be a big challenge for big industries, but for SMEs that have a more limited budget, in order to implement predictive maintenance, it could be quite difficult and complex. Moving to the last two barriers, a huge challenge is the human factor. With the new technologies, the humans, the people in the workforce may be afraid to use this new challenge of fear of losing their jobs and their jobs. Also, it's important to mention that in order to use this challenge, you should have the knowledge to interpret the data and the results found through predictive maintenance and uncover anomalies in order to exploit this technology in its potential, in its full potential. Now, moving to the aim and the industry needs, well, the aim of the level up was to improve the maintenance practices and extend the remaining useful life of the equipment. As Stefano mentioned, we have 7 use cases. These use cases were used to test and validate the level up components and see if we can reach our target. Following a use case analysis, we derived the needs and the requirements of these pilots. The main goals of all of them was how to increase performance and quality, how to increase productivity while reducing the operation costs. They wanted reliability in the results in their products, and as well as advancing the useful lifetime of their machines. Here comes the predictive maintenance. How can predictive maintenance support these goals? Well, predictive maintenance offers real-time condition monitoring. It supports the data collection and exchange of information between the systems and the people that are using the software. And by using advanced data analysis and modeling, it can detect and predict failures. In order now to achieve the aim of the level up, which is the advanced operational maintenance procedures and extending the useful life, level up defined 8 strategies. Really fast, these 8 strategies are to predict faults, to early detect faults, or to prevent the propagation of the failures, to estimate the remaining useful life of the machines, to manage all the strategies that have been developed, to detect the characteristics of the failure, as well as at the end to move to repair or refurbishment or remanufacturing actions. These strategies are interconnected together. The idea is to apply a holistic approach that can help move the factory's plan from reactive or preventive to predictive. Now, these strategies combined with the components developed in the level up. Now, in this presentation, we are focusing on the predictive maintenance. So the components that are correlated with these strategies are predictive tools, and the strategies are mainly the predict, the diagnose, and the estimate strategy. As also Andreas and Stefano mentioned, we had 10 protocols, which are interconnected. What we're focusing here is protocol 1, which is about the functional diagnosis. This protocol includes condition monitoring, simulations, anomaly detection, and prediction of failures. And using this data that we derive from these actions, we have the defined KPIs from the pilots. We can see our progress in predictive maintenance, as well as calculate the efficiency of the machines. Now moving on to the tools. We have 2 tools. I will start with predictive maintenance platform, which was developed by Atlantis. This predictive maintenance platform was applied to 4 pilots, ISO, Contosoling, Trilink, and ESMA. The main functionalities of the pilots are real-time condition monitoring. By using unsupervised and semi-supervised techniques, we have fault detection, as well as we have prediction by using supervised techniques. The characteristics of this platform is that it is based on microservice architecture that promotes versatility and stability. It can offer a user authorization service, while the user can initialize the analytical task with no much effort. Also, in the right side of this slide, we can see 2 user interfaces of the platform. The platform can send notifications and alerts to the user in a color-coded way, while the user can, by just a click, see the dataset that can be received. Moving about the results. Now, as I have mentioned, we have 4 pilots. In the first pilot, the main focus area was how we can predict next values. In the left up side, we can see the actual and predicted values compared together. As we can see, the trend is quite similar. This diagram could be transformed based on average values to the diagram below if the user needs to have a more easy to understand diagram. In the ISOCOM pilot, we have focused on vibration analysis, where we receive the signal, filtered and applied transformations, and the aim was to detect faults. However, during the progress of the project, we have also included more parameters, such as the vacuum pressure. Moving to the last 2 pilots, in the TRIMEC pilot, the idea was also to use the prediction service. From the left diagram, we can see that both the actual values and the predicted values follow the same trend. At the last pilot ESMA, the analysis was focused on the fiber optic sensors, where we recognized and detected patterns of the false data. Now, the second predictive tool is the machine state forecasting developed by Core. This is also a tool that can provide real-time condition monitoring, anomaly detection, as well as time series prediction. Well, some of the highlights of this tool is that it uses state-of-the-art deep learning autoencoder architecture to extract time series to extract the features. Also, it has machine learning operation workflows for model and data versioning. It is based also in robust microservice architectures for streaming data pipelines, and it has inference production real environment for serving deep learning models at scale. The last 2 highlights is that it also offers user authorization services and visualization dashboards, where we can see in the right side of the slide. Here we can see 3 dashboards from 3 different pilots, Tosulin, Lucchini, and ESMA. However, also this tool was applied in 4 pilots, and 4 different pilots, including the IPC. Now, moving on to the results, let's start with the Lucchini. Here, the service that was provided was anomaly detection. So the idea was how to detect the anomalies. This model that was developed was validated by comparing detected events by the model by the maintenance logs. So the detected events are signs that something is malfunctioning in the equipment, and an action should be taken in order to prevent this malfunction to propagate. Moving on to the ESMA pilot, also the anomaly detection service here was applied and also cross-validated based on the detected events and the maintenance logs. Finally, in the Tosulin pilot, the idea was to apply the prediction service on the particles, on the oil particles. Here, the models were evaluated based on the predictions against the labeled data points. Moving on to the last part of my presentation, I have listed 3 barriers that could hinder the progress of the predictive maintenance. It's the lack of skilled workforce, the ownership and privacy of data, and the traditional equipment. If we take them from the start, in order to efficiently implement predictive maintenance, the workforce should be skilled and be trained. Also, it is necessary to know how to use the software and how the software works. The companies on this account need expertise in areas such as cybersecurity to protect the data, the applications, which are the softwares, and the networking, which is the connectivity between the softwares and the systems already included. The second barrier, which is about the data, by introduction of new technologies, the speed of which we are gathering data or the amount of data is highly increased. So for all the enterprises, for every organization, data management is quite a limiting factor on their processes, since all the data should be protected. Also, something that leads to this barrier is that the models, the methods and techniques that we can apply to transfer data from a system to another can be quite limited. And the last barrier is about the hardware. Old legacy equipment may be quite difficult to be connected with new sensors or IoT connections. Here comes the necessity of modernize the equipment, moving from the old technologies to new technologies in order to tackle this barrier. Nonetheless, I believe that already steps have been taken to start tackling these barriers and applying predictive maintenance to the industry, moving to Industry 4.0. Thank you.
Any questions? Yes, Matthew.
Hi, this is Roberto. I was wondering if you could elaborate a bit on I would see hard work on gathering data for failure mode for predictive maintenance in ongoing existing equipment, assuming that it's not that frequent that you have data sources for doing that in real production as long as they're working properly, and how you handle it.
The data is quite a big problem. In order to apply the advanced modeling, you have to have a large quantity of data and possible from different sources. Some sectors, some businesses in the manufacturing sector already has a great variety of data from their PLCs on the ERP systems, and also we have already included some sensors to receive data. Nonetheless, at least for the level up, the modernization was a part of the process, of the level up process, as well as the installation of new data, of new sensors, sorry. So these data were received from us, were categorized, and our models were trained. For sure, to correlate the failures with the data, it needs the support of the industry. Otherwise, we can't go blind and say that, okay, this is it, this is it. I'm not sure if I have answered your question exactly or.
Just a question about your last slide regarding the barriers in order to skill the workforce.
Yeah.
Which are the main barriers or the main skills that should be improved in the work?
For sure, I think that the maintenance teams in the industry should be able to use the softwares installed and understand the technologies used, since they are the first line of to correct something if it is broken. So they need to have some basic knowledge on data analysis, since the predictive maintenance, it gives information about the data and the failures, but in order to take it a step further, you have to be able to interpret this data correctly. Also, if we move more to a more hardware part, you have to know how the systems connect with each other, because there may be disconnections and you have to correct them, or you have to be able to understand the need that maybe new hardware is needed to understand the problem. Anyway, the technology providers can support the industry in this. It's not that we're just giving the software and we leave the industry to do what it can do. It's part of our job, I think, to say that, okay, maybe with this new sensor, if you apply it in your machine, we can have some data that can lead to understanding the failures and what the failure is and where the failure is in your machine.
Hello, Wim van Kouwenberger from BEMAS Belgian Maintenance Society. And maybe you can revert back to the slide on lubrication. Yes, I think that's the one, or the next one, yes. A question. On what type of sensor was this data applied? And the second question then, was it combined with other data in order to come to these conclusions? And did you have a correlation, or did you check if the conclusions there for predicting failures, I guess with the oil, are proved to be real or correct or not?
Well, these are the results from our partner Core, so maybe it's better for the leaders to answer this question.
Yes, I can answer to this question, but probably Tosman will be most to give you the sensor details. But I think that what we see is the outliers we have in the oil distribution about the corrective sizes you see, and we had the sensor was inside the machine. They also had another sensor in their own machine, and we had data for the old machine also about the oil quality and the particle count. And after the modernization of their equipment, those data were also taken from the new machine, and we made the comparison, and we have validated on the old machine and validated also on the new machine. And you see the outliers where we have detected the concentration that is higher than expected. Thank you too.
Thank you. Thank you, Zinzis.
You're welcome.
Now we have Marco from Thinking Additive. He's a software lead at Thinking Additive, has a PhD on advanced slicing methods in multi-axis additive manufacturing. His current focus is on software architecture and computational geometry. Please.
Thank you, Asif. Good morning, everyone. Today I'll be speaking to you about the role of additive manufacturing in reverse supply chain. I think it would be a good idea to start from the direct supply chain, and we could probably complicate this schematic as much as we want, depending on the industry as well. But for as far as large industrial equipment goes, I think this suffices to start from the suppliers, which basically provide either the raw materials or semi-finished products to the original equipment manufacturers. So these are the original team, original machine builders, who then provide their machines to a seller, who in turn then sells the machine to an end user and provides an added value on the market in some way. In some occasions, of course, the OEM and the seller are the same entity. Now, what happens when there is a situation of a no longer fit part at the end user? So one of the first options that comes to mind is to try and contact the seller again and ask if they have some kind of a strategy put in place already. And of course, one of the considerations that will be made is to replace this part with a new one, and probably dispose of the old one or recycle it, or any other kind of end-of-life strategy that is put in place. What we are trying to look in the Level Up project is try to analyze if it makes sense, when it makes sense to, and how to repair a certain part to extend the useful life. So in this case, the seller might need to contact the original equipment manufacturer if they offer this as a service, or otherwise the direct supply chain does not even have to be included. This repair can go through a repair hub as well. So in this way, a reverse supply chain is created where the part moves from the end user back to a facility where it gets repaired, and then it gets transferred again to the end user to extend the useful life. And the part itself does not need to be with the catastrophic failures such as the gear that you see here. I mean, it can also be just worn out. obsolete with respect to the rest of the equipment, or unfit according to any other quality criteria. So there is a direct industrial need to provide a technology, this collective of tools and services that extend the useful life of industrial equipment. And of course, they do this by adding value. Otherwise, there would be no incentive to kind of for this solution to get picked up by the industry. And additive manufacturing is particularly a good candidate for this because it provides an opportunity for the repair process to be fully digitalized and to offer repeatability and hence offer a final predicted quality of the part. And so the aim would be to address these issues and develop this technology to repair the part, but also to upgrade it. Upgrade would be pretty much same as repair, but we are saying, well, while we are repairing, might as well use better materials and try to improve some of the original characteristics of the part. Now, considering adoption challenges, some of the issues that we've noticed and we try to address in Level Up, we saw three main issues. First of all, of course, the technological development and how we go about in repairing a part. The second one is decision support. So this is crucial, I believe, for uptake by the industry. We need to help a potential user understand if it makes sense to repair a part, and then help him also on how to do this. And then the third one is the logistical element. So because of the nature of the reverse supply chain, we need to move the part twice. So it needs to go from the end user to a repair facility back to the end user, as opposed to the direct supply chain where it just gets transferred once. So regarding the first issue, we've spent a considerable amount of time and effort in developing technical solutions within the Level Up project. So currently, the pipeline that we follow is the following one. We start from the scanning, digital acquisition of the part to try and assess the damage that has been done. We then pre-machine the part that is no longer valid, so that we kind of set the base, a good base for the additive manufacturing process. We then apply selective slicing and process planning on how to execute the additive manufacturing part. And then we simulate this before execution. The simulation concerns three aspects, at least three aspects, I believe. Most of the time, I think it can also concern thermal one, but mostly we simulate crack susceptibility of the material, distortions, and internal stresses. And so there is an iterative kind of process going on between the process planning and the simulation, because if we see that there is something wrong and we have a bad signal from the simulation, then we try to modify something in the process planning, and we try to optimize this in an iterative cycle. We then execute the process itself by direct energy deposition, technology that seems most suitable for repair from additive manufacturing. And then we have the finishing part that actually in some occasions, as we will see later, can also be even avoided. Then considering the second issue, the decision support, in Level Up, we're also working on an inclusive model to try and consider financial, sustainability, and temporal aspects whenever we try to decide whether or not it makes sense to repair a part. And in fact, when we do the process planning within the pipeline, we know exactly how long the repair is going to take, how much material is going to be used or wasted, and also other auxiliary expenses such as electricity consumption, inert gases, and similar parameters. Finally, for the logistics issue, we worked on the in situ repair cell. This is a solution that basically concentrates all of the technology within a repair cell that can either be shipped or transported closer to the end user, so that in cases where we have big or really heavy parts, and transport is a problem, we can try to minimize the effect of that. In the following slides, I'll show you some of the results. So relating directly to the logistical parts and issues, this is one part that weighed over 2 tons, 2.5 tons. So it helps you get a sense of the size of the gear that I showed you in the beginning with the broken teeth. And you can see in the second image, this is a solution that can also be applied within the in situ cell, but it also pushes the concept of in situ repair even further by providing the robot on a structure. So ideally, and with time, we can also come up with solutions that even repair the part when it's not even disassembled from the machine. This would be the optimal solution, as it will allow us to save time on disassembly as well. But yeah, just to provide you with a bit of context, and then you can see in this case it was a cobot with the wire-based direct energy deposition process, and that's how the repair went about. Then in the second use case we have Tosculin. In this case, we were repairing a part that is right under the bed into in a vertical lathe CNC machine, and this part purpose is to keep the coolant and chip out of the drivetrain. So the repair is that segment, the green segment that you see on the sketch. Basically, with time, it gets eaten out. You can see also in the image on how the profile has been worn out. So basically, we proceed with scanning. In this case, we also did simulations on how to analyze if preheating is needed of the part and how much would this be of benefit. And then we go ahead and we do the deposition process. This is the this is powder-based direct energy deposition, but it's a sped up animation. So this is not the real speed of the process. Right. This part was actually a very effective part to be repaired, and the financial gains, as opposed to replacing it with a new part, were quite substantial. Also because of the fact that we managed to finish the part and to enter within the geometrical tolerances only with the additive manufacturing part without any final finishing needed. So I think this saved a little bit on the repair process that you could not always have as a situation. So it was a particularly positive experience. Then we have Trimec. In this case, we had an air bearing that was consumed by the use. And in the image on the bottom left, you can see a first try to apply a repair coating on top of the part and try to repair it. We had limited success, as you can see, because of the way the part was made and the final characteristics regarding hardness of the material. We suspect that was the issue, and so in this case, a particularly high effect was gained from the simulations. Simulations helped us understand to change from material X to material Y, which then allowed us to repair the part and bring it within tolerances. So that's the part after final machining. Lastly, we have Isocon. Isocon is a case of an extrusion die, repair of an extrusion die within the caravan industry. So it's the die is it's an assembly. It's not a particularly big element, but it's quite complicated as it's the parts are quite intricate. And you can see in the areas in blue, the parts that have been the zones that have been kind of worn out, and these are the parts that we needed to repair. So we proceeded with scanning to kind of analyze what damage are we dealing with and what is the amount of material that needs to be repaired. Then we proceed to analyze selective slicing and plan on how the process should be done. In this use case, there was also particular attention put into place to the motion aspect of the process planning, because we needed to sort of dance around the existing geometry. So this needs to be checked both from the process point of view and then also physical collisions. And we were also supported from the simulations for distortion point of view and internal stresses. I think that concludes. Oh yeah, we have some final images of the repair process. So you can see, I think this is part one from the assembly being repaired and how the repair process goes basically in the lab. I'll close down with the final slide on future challenges and opportunities. I believe that we are on the right track to improve the technology in this area, and I think big steps have been made in the Level Up project. Future work, I think, should be organized around bringing automation to the entire iterative process of the digital pipeline within the repair. So if we can make the process planning together with the simulation to be executed into sort of one mega software, that would be, I think, quite beneficial, as it would try and save some time on the of the design of experiments. So this is one part of the pipeline that I deliberately kind of left out, but every time that we need to repair, we need to understand what are the optimal parameters for the additive manufacturing process, and a lot of time is lost on this. So if we can optimize this, it would be very nice. And the other aspect, I think we should try to also include either online monitoring or final inspection of the part. This way we can tell the user and guarantee a certain level of quality after the repair of the part has been done. The second aspect is ecosystem growth. So I think we need to educate, we need to disseminate what we know, what we've done, and hopefully facilitate investments in this area, because especially for SMEs, this is a particularly hard part to bring within the company itself, because large capital investment needs to be done from the start. So externalizing some of these services could be quite useful. That's everything from my side. If there are any questions, let me know.
Yeah.
Thank you. Isaac Chang from Brunel University. Yeah, very impressive result showing the repaired component. So my sort of interest will be, you mentioned at the end about quality of the repaired parts.
Yes.
But my interest will be, what about the performance of the repair part? Has any of those repair parts been put back into the service? And if so, what is their performance compared to a new component, for example?
Yes, I believe the plan is to reintroduce within the manufacturing process and the manufacturing line of at least one of the components that we are repairing. We are still trying to finalize one of the pieces. I don't believe that any of these components have already been reintroduced inside of the parts. The one, please correct me if I'm wrong, also for the air bearing, I believe it hasn't been finally reintroduced inside of the machine. The only feedback regarding this and the final quality has been from the part that I discussed previously, the sealant. As far as I know, the last plans from Tosculin were not including to introduce this part into the machine, even though we are within kind of geometrical tolerances. So we have another month and a half, I think, to kind of close the project. And I don't know if something is going to be reintroduced inside of a production kind of line within the month and a half that we have left. But so far, no, we don't have an experience of directly reintroducing a repair part inside the machine, unfortunately.
Because that would be a definitive proof.
Exactly.
Success.
Yes,
Yeah.
I completely agree. Yeah.
Thanks for the presentation. Just a small question is, I understood that in one of the use cases, it was possible to repair using additive without a final polishing of the components.
Yes.
Yeah. So this is possible. Really, the quality of the additive is enough to comply with the final surface or?
It really depends on the part. Of course, if this is a part that goes into a turbine engine, I highly doubt that we are going to be able to produce the part just by additive manufacturing without final finishing. However, in this case, it was not a critical component from the motion, let's say, aspect of the machine or quality inspection or the tool itself. It's a part that it acts as a sealant. And actually, that part is being already repaired using standard procedures by Tosculin, and they're trying to avoid that. So currently, they're repairing it by providing inserts. So the part itself does not have requirements, this high requirements of regarding dimensions from the start. So this depends on basically on the part. It's not a critical component, and in this case, the accuracy of additive manufacturing, I think we were within plus and minus 600 microns. So it's about of a millimeter of a total range, and that was enough for the sealant to do its job, basically.
And another question, you mentioned the idea of in situ repair, machining and additive without disassembling the component.
Yes.
Do you have experience in this field, or is just the?
Personally, no. There are projects going on. I believe there is either from Siemens or General Electric a part that deals with this, and they try to fix some high-end components by introducing the robot directly on top of the assembly, trying to do the repair. Some of it sounds like science fiction. There are other projects that are also developing kind of parallel robots to try and do this. I believe it's the correct way to go, and I think it's inevitable for this to be the future. Now, if it's going to happen in 5 years or if it's going to take us 20, I don't know. But I think that there are projects already going on in this direction.
Okay, thanks.
Okay, maybe a quick question from me. So yeah, there's a lot of questions around repair versus replacements. Where companies, industries with big budgets, they can't easy to make a decision. But when it comes to small and medium enterprises, there's always this question. So should we go for a repair or for a replacement of ifs and buts? My question would be like, are there any category of parts which will pay off with this approach for the repair?
There isn't really a definitive answer. From what I have seen and literature, I think we can kind of lump two categories of parts. So it's either really big, and with the repair, we can only affect, let's say 0.5% or 1% or 2% of the entire volume of the part. So you save a lot of material, time, and effort into repairing the part. Or it can also be a smaller, like in some of the situations that we had here, parts with quite the limited dimensions, but they're very intricate and delicate on the inside, or they're really high cost to make. So I would probably select these two groups. It's either really big and repair can also be done in situ, and this helps the repair process, or it's really complicated part and it costs a lot to remanufacture it completely. So these two cases that probably would benefit most.
Okay, thank you. Okay, thank you, Martin.
Thank you.
Okay, with this, probably we'll take a 10-minute break and we come back. So there is coffee on the other room. So please join back in 10 minutes. Thank you.
Thank you.
So after a coffee break, I was talking to one of my colleagues here, so it's very difficult to get people back from the coffee. So always. Okay, now yeah, the next person I think I don't have to introduce, but for the sake of formality, I will still do it. For the people who have been here for the last 2 days, you already know him, but for just the sake of the formality. So Chris is from EFRA. He has a master's in electromechanical engineering. He got fairly quickly involved in European research and innovation programs. Currently at EFRA, Chris supports the consensus building about research innovation priorities among the industrial and research community, mainly for the Made in Europe partnership under Horizon Europe. He supports monitoring of the outcome and progress of the factories of the future and Made in Europe partnership, and works on knowledge transfer mechanisms that enhance the impact of this research and innovation program. So here, Chris, for you.
Thanks. Thanks a lot, thanks a lot, people here and people online and watching this later, hopefully. So yes, well, that was a mouthful, so don't worry about, different things I do, but basically in a nutshell, yeah, I'm involved in EFRA in terms of, priorities for the future and also looking at what projects are doing. I should have written that in terms of the introduction instead of the long sentence I wrote. So thanks a lot for having me. It's much appreciated, to see also in more detail what projects have come forward with. As you referred to the events yesterday, where, in like 15 minutes, we, in a nutshell, tried to capture, and that worked well. But it's always nice to have some more time to spend with projects. So I appreciate the occasion a lot. So if all is well, yeah, next slide is showing actually part of that perspective that, as you mentioned in the introduction, is like the priority building. And considering the scope of this session, I'm highlighting straight away something. So what you see there is the Made in Europe framework of the Strategic Research and Innovation Agenda. Obviously, what EFRA does is communicating to the Commission priorities for the future and link that to policies that the Commission also finds important. And on the left-hand side, you see basically these policies, and the Green Deal is one of them, competitiveness is another. And I think the examples that are shown also today show it's all about being efficient, doing the circular loop, but being efficient cost-wise as well. And I think it's examples that really speak, that I already saw here, that show the real work, what companies are dealing with and the challenges they're dealing with them. It's nice to see that perspective. But circularity has many faces, if you wish, and I will try to give kind of a helicopter view of this perspective from the perspective of the Factories of Future partnership and the Made in Europe partnership. Obviously, there's a whole stack of technologies that you've already shown in your presentations that we need to integrate, and integration is the key word. From the technological perspective, but also from the organizational perspective, and this was also mentioned from the logistic perspective. There's everything basically, and this is important already in this perspective. Circular manufacturing. When I was invited to give this presentation and a kind of keynote, I was thinking to myself, okay, how do I do this? It's like a general perspective, an ecosystem perspective. And what I did is I went to the EFRA portal and simply put circular there in free text and see what I got, saying, okay, what does the program do? And that's the first page of projects that came up. And I found that interesting to me, already showing different points, what projects do also in the past relating to this. And luckily you appeared on that first page. And I will comment a few of those projects that appeared there, and DigiPrime also featuring in the manufacturing partners days yesterday is one of the, I would say, first real circular projects, not saying anything bad about what happened before, but about, you know, the point of having value networks interacting with one another, where there, for instance, there's an example of the batteries, looking for the second life of a battery. You have battery and mobility systems, cars. A potential second life of a battery would be an energy system for a building. So it's really two value networks joining together, and that's really an ecosystem perspective. There's ecosystem perspectives everywhere, but there it's really very tangible what different ecosystems, how they should integrate, and that matter of integration makes it even more challenging, I would say. But also there's a bigger opportunity there, and that's a project that finished. Also now, actually, from the 2000, well, it is finishing from the 2019 call from FOM. Piclos is a project from the same call, also looking into circularity, a bit more orienting also the human aspect in it. We heard about human aspects, we heard about that. And then I'd like to refer to, well, it's on the slide, so I will refer to anything there, just putting into perspective, the EFPF, European Factory Platform. And there it's all about the digital side of things, where you have, you know, you have platforms for everything. Every digital solution has its, you know, strong points, maybe also some weak points. And then if, you know, a user, a manufacturing company is tempted already to maybe look after, you know, the modernization in terms of an ERP system and an MES system, there already, you know, the challenge starts in what to choose and how to connect them, let alone that there would be an app out somewhere that says, well, you know, if I get your data, I will have the best anomaly detection you can dream of. And you've been talking about anomaly detection. So you would say, okay, you need a platform to watch out for which, for my process, is the best anomaly detection. And then the point is, okay, so I will need to provide these data, my data, to these people. Will I do it? What's the benefit? What's the ownership? Things we heard in the previous presentations. So EFPF has been looking at the federation of platforms and dealing with exchanging data and connecting data. Clearly in circular, it's a major thing to be done in order to get things to work, also across value networks. And well, there you come with Reclaim and Level Up. And I thought to join you with a project there, which is called Sustainably Smart. And sustainable smart mobile devices lifecycle through advanced redesign, reliability, and reuse and remanufacturing technologies. Project started in 2015. So clearly there's really already a flow of projects addressing this, and from the ones that are finishing, Reclaim, and Michael Bescher will be in the panel, so we're happy also to have his point of view of that, and Level Up are part of this storyline. Looking maybe less at the value network level that I commented when DigiPrime is commenting DigiPrime. It's more about, you know, the example we heard about the gear, and, you know, you want to have the system working as long as possible. First, you monitor the system so that the gear in that system works well. As soon as something's going wrong, you will ask yourself, why is it going wrong? And can we repair that gear, and what it takes to repair the gear? So that's the type of capital investment equipment perspectives that we see in these projects. So we see the different perspectives appear, and then comes in a Made in Europe call that's been calling for AI and sustainability. And then we see, you know, the flow of, and I heard it also. We discussed briefly in the coffee break. You know, the zeroth effect flow of projects, the quality type of kind of projects coming in. And Circular Twain is definitely one of them, saying, okay, we have to know our processes, we have to use AI to know those processes. It's self-X, right? It's been mentioned also before. So doing everything right with AI, including then the circular aspect, and there the digital tools coming. And more digital tools have been called for in another call topic in Made in Europe, digital assessment. I mean, it's a bit linked to the digital product passport approach. And we see projects that look more into, well, AI for sure, but then linking the AI with the simulation, the digital twins, etc., which of course helps to assess also the state of a system and assess whether a system needs to be repaired or not, and what's the options. So there's really a whole ecosystem of projects out there that somehow link to also things that you have been doing. And I'm quite sure there's like also a flow of information from your project going into those projects, and we're happy as EFRA to support that flow and to make everything valorized what you do, so it's not staying in the drawer. One particular aspect that came in doing that search, it's the bio-based materials project that have been called for also under Made in Europe. So that's a totally different perspective, obviously, in terms of circular. I will not go into the bio discussion and all that, but simply looking at materials and the reuse of materials. I was thinking about the gear, for instance. You say, well, you try to repair the gear. At some point, you might think, well, the gear is lost. And what if the gear is lost? You would try to recover the material and make another gear or something else with that material. I think the whole material perspective is a very important one in the circular manufacturing ecosystem. So there's so many perspectives to look at it. So that's one thing I thought I'd comment from the helicopter view perspective. And then I looked at the website also and some of the material you did, and this is a slide I saw already. I think it was in Stefano's presentation, something close to this in the modernization point, right? Well, that's what it says as well. And it reminded me of the Integrate project picture about the digital pipeline, which for me, honestly, was kind of more easy to grasp. You say, well, you're in a factory, you design something, you have computer-aided design techniques to do that. You would think about manufacturing and do the CAD/CAM, and then, well, you continue in the flow, and then you would then have actually the manufacturing being done. You have metrology to see, if everything's according to specs. There's some post-processing, which reminds me of even the repair type of phase. And then you certify according also to specs, what your supplier requires, and you try to do the utmost to connect all these systems. So you have this digital pipeline following the materials and components pipeline. And what you have been doing also is maybe from a bit different perspective. It's putting everything in place so you can really start doing that type of stuff, really connecting and then having like JSON formats being mapped on something else, on ontologies to make this work. And I mean, every project I hear about almost is really addressing this. And that's maybe one thing that I'd really be keen to follow up with is really, the key methodologies to make it happen. And so that when there's a general perception from industry saying, what do we get out of these projects is to grasp, what's the best way to do this modernization and what's the best practices in making all that happen. It supports circularity, but it supports everything. It supports the full range. Sorry. I already made reference to the Made in Europe calls that happened before. And, the two set of projects, groups of projects that I mentioned in the previous slide came from actually artificial intelligence for sustainable and agile manufacturing and digital tools to support engineering and circular economy. So definitely there's a flow of, green and digital within the twin transition. it says it all. That's why it's called transition, basically. And in terms of, I will make a comment about something else afterwards. Just thinking it's about this that I will make a comment, but I will go back first, or hang on, just say the next calls, the call that's open with deadline beginning next year. There's also technology solutions to support circularity for manufacturing. So there's quite a few of opportunities that are providing this technology perspective. Now I will go back to this. The thing we've also been discussing in the coffee break is the priorities for the next work programs, where EFA has been doing consultation, which is actually still open. We keep that line open, not to put people off, where all these aspects somehow come back. Oh, sorry. There it is. So circularity from the ecosystem perspective, in a value network perspective, and circularity from the zero defect remanufacturing perspective, because remanufacturing, it will not be perceived as let's try and see what comes out of it. We'll put some welding and see if we have good quality, and then maybe we have to grind it if it's not according to specs. It's really knowing what you can do with the component that is worn out, perhaps, and then do the right thing in a very cost-efficient way to get it back into an operational condition. So that's what we also try to highlight there with these priorities, and also covering the new limited raw materials perspective, saying, okay, at some point you would look more at the material of the component rather than the functionality if the component is fully lost. So clearly these aspects come in. Also looking at the life cycle management and associated services. So clearly these aspects are very keen to us, and linked to the one on top there on excellence, productive and flexible manufacturing automation for open strategic autonomy. In the discussion during the break, I've heard that, you know, quality and predictive maintenance and zero defect, it's a very important topic. We see it more and more being embedded sometimes with some other topics, but clearly it's not a coincidence that it's there on top of the agenda, because really excellence and top quality is a major thing to do. Okay, that's it for now. And with this, I'm happy to also get some questions, or later on I will be in the panel, so I'll be happy to discuss with you as well.
Questions, please. Thanks, Chris, for participating. It's a general question. Internally, we have talked in the lab and in many other places how to improve the visibility and the impact of these projects, not only for the Commission, also for the industry. So, you know, we are making a lot of reporting, disseminating the results in different events, technical conferences, and so on. Mm-hmm. So, do you see another way also that you put a lot of different projects together? Mm-hmm. There are some clusters of projects trying to build, you know, an umbrella dissemination for making. Do you see a way to reach more audience in order to show?
In terms of an audience, I mean, I showed pictures, screenshots from the EFA Innovation Portal. I think that's the way it is now, more for the research and innovation ecosystem. I think the whole point of getting technologies in a company is about a company, I think, still reaching out to a local service provider. Well, there's talk about digital innovation hubs. I think before we talked about digital innovation hubs, these local centers, including the one that are in this consortium, have been there, and they're keen to help the companies they live with, they work with. And I think what at least we should achieve is that every RTO has a very good view on really useful approaches and technologies that have been generated in different projects. And if it's not commercialized yet, because I think for a company to modernize, I think you would rather have proven technology and say, you know, what do I need to buy? And I buy it, and then I need to integrate it, and I need a system integrator to integrate it. If that's still not straight away available, I think then it's for probably the RTOs to have more like contract research and development. And then with the European ecosystem to see, you know, which competencies you need and possible services to make it happen for that company. And I think that level of ecosystem is something that I think we're keen to nurture, whether it's through European digital innovation hubs. For me, it doesn't matter as long as the RTO has its network and can solve problems for its local industries.
Hi, Chris. Isaac Shank for Brunel. So you talked about this sort of circularities about ecosystems, integrations, but it's only looking from the angles of technologies, AI's materials. So I'm just wondering what about the business model side, because at the end of the day, you need the business to take on board of the circularities. So I don't know whether, what is the business angle?
Well, the first example I pointed at, and maybe I'll straight away go back to that slide. DigiPrime, where the example is, you know, the battery value network, and then you have the energy systems value network where batteries are also of relevance. In that project, well, that example shows actually the use case. It's all about use cases. All of these projects have use cases. And thank you for reminding me of saying that there are use cases in these projects, and that's an essential component in every Factories of Future Made in Europe project, is that the use case, whether it's a gear or it's a cover, a bed cover that was shown, or whether it's a battery. DigiPrime does mechatronic systems. I mean, we know, for instance, also that like electric drives, there's really big suppliers of electric drives that really think about having these electric drives in a second life and what's needed to have the electric drives in the second life. So there's already component builders, manufacturers that really look into this. And the point is to have the use cases, particularly with these sectors involved, so that the technologies are injected within these use cases. Now, the business case, some projects, you know, look into, you know, the economic viability of doing it. But still, I think it's that there's a whole mindset change required across different layers in companies to have the circular mindset to see it as a business case. So it's really a wide challenge. It's true that from the digital side, there's a lot of technologies being injected, and I'm totally with you to see, well, you can maybe do something with all those graphs and anomaly detections and everything, but somebody has to see the value in them. Totally with you about that. Yeah.
Okay, for me, it's more of a comment than a question. So yeah, to complement the discussion. Yes, I think that we clearly see a gap in measuring the impact of these projects in the industry. Solutions by you, the RTOs should take the lead, and the use of digital hubs could be one of the solutions. But yeah, this gap is still there. Yeah, there is a lot of know-how, but we are still missing the deployment and implementation of these results in the industry cases.
Yeah. With regard to circularity in terms of projects, what we see now is really a bigger portfolio of projects that somehow address these different perspectives, and the results are coming out of like the one like Level Up. Because before, you know, basically that was sustainably smart. DigiPrime started as one, you know, how you call it, lighthouse type of project, and now we see, you know, more projects doing that. So we'll need to capture the results and see, you know, which direction it will help industry.
Thank you, Chris.
Thank you.
now Boris from DSS Plus, he studied engineering and international development, worked for a decade in the field of circular economy, so it's not something new for him. So joined as a senior consultant at DSS. Current role involves advising public and private bodies issues related to circular economy and other sustainable matters. Boris, please.
All right, thank you for the introduction. And you were right in not attempting to say my last name because it's a difficult one. All right, so we're going to talk about, in this small session, about end-of-life management and decision support tools. So our work at DSS Plus, so formerly that was Sophius at the beginning of the project, our work focused on enabling decision-making. So as, for example, Marco was saying earlier, repairing a piece can make sense instead of changing the whole, instead of acquiring a new machine, right? However, how much does it make sense? What is the environmental benefit that you draw from it? How can you quantify this? And also, do you save money, or does it prove to be more expensive in the long run? But those are the questions that we focus on within our contribution to the level of project. So it's about really producing the right information that enables decision making by comparing the merits of different scenarios, different decisions regarding sustainability and also regarding economic cost. So just as a very quick reminder, our approach for looking at these aspects is an approach which targets the entire life cycle of a product, as should be. When you're looking at an end of life scenario, you're not only comparing the impacts on what happens in the end of life, you're actually looking at the entire life cycle of the product. So I assume this is nothing new to all of you, so I'm gonna skim through this quickly. But we're looking at all the phases from raw material extraction all the way to end of use, because a decision made at any of those stages actually can have effect on all of those. Of course, so we are at Level Up, we were targeting life extension as a priority, and so in terms of in the terms of a classic waste hierarchy, this translates into prevention and reuse. Those are the practices that our objective was to promote those practices over the rest, and so this translates into remanufacturing, modernizing, repairing, and reusing. So now, what did we concretely do? We produced 3 tools. The first tool is an environmental assessment tool. So what's the goal of this? It's really to help a decision maker assess, as I was saying, the consequences of different scenarios in terms of environmental impact and economic impact as well. The repair assessment tool is a spin-off of that environmental assessment tool, which was specifically targeting repair scenarios, especially the repair practices that we've been working on and developing within this project. And the third one is the waste management tool. So this is, well, a bit less about circular economy, but still circular economy. Insofar that the overall goal of circular economy is arguably to just avoid waste, but at some point you can't avoid it anymore. And therefore, we produced this tool to provide some high-level guidance to the companies regarding what should be done depending on what material flow we're talking about, depending on the geography, targeting both the regulations and the local existing best practices. So for the environmental assessment tool, so what was the goal exactly? The goal was to obviously assess the environmental impact, right? Looking at the full life cycle of the product, as I said a minute ago. So what that means is that we're trying to provide a full picture of the environmental impacts, to compare environmental impacts of different scenarios. So for example, is it better to repair certain pieces or to use your money rather to increase the productivity of your machine? What is going to have the better environmental impact between these two things? It's a bit difficult to say. And well, it is possible to say because, well, there are methodologies for that. So of course, to work on this, we used what's called the life cycle analysis methodology. So we've been looking, of course, at the CO2 footprints, the greenhouse gas emissions. However, not only that, because greenhouse gas emissions are just one of the numerous ways that an activity impacts the environment. In the classic LCA methodology, you have 15 different impact factors, and carbon dioxide is just one of them. Here in the scope of this project, we look at 10 of those 15 impact factors, just because some of them were more relevant than others. And of course, carbon dioxide was included. However, as I was saying, not only that. So the challenge with quantification of environmental impacts is that it's a relatively data-intensive process. If you want to have some good results, you need some good data in the entrance. And well, I was not the first to say that between the different people who presented before, right? So obviously the quality of the data and its collection are critical. And with sustainability matters, I would say there is an added issue, which is that if the effort of collecting the data is too big, then at some point, the decision maker can start asking themselves, is it actually worth it? It's a really big effort. Because sustainability is increasingly important for companies, right? But in most cases, it's yet not as important as the raw bottom line in the end. Therefore, there's also this question: how do you streamline? How do you make the process simpler while not sacrificing too much quality in the end? So it's actually a matter of compromise, a matter of arbitration. The more effort you will have, in the collection of the data, the better quality your results are going to be. However, that effort it will have an impact on the decision making. So yeah, compromise, as I was saying. So we did our best to assess those environmental impacts and to allow the decision makers to understand the consequences of their decisions, the implications on the environmental point of view and also the economic point of view. And also we needed those tools that were developed to be applicable to a wide range of scenarios, not only to just one thing, because otherwise, I mean, what's the point, right? So those tools needed to be available to be applicable to different equipments and also different scenarios, such as productivity increase, such as repair, such as retrofitting, such as, of course, replacing by new equipment, etc. So we needed to have the ability to simulate all those different scenarios for a wide range of potential equipment. That was a big challenge. And of course, at the end, it needs to be easy to use and flexible, otherwise no one's going to use it. Simple enough. So this is simply enough what it looked like. So we developed a prototype on Excel format, which was later integrated into the decision support system. And so the parameters in entrance include factors such as the ones you can see to the left. And based on that, so the tool is leveraging data from databases such as EcoInvent in order to aggregate and calculate the resulting environmental impacts for several scenarios. The interesting part of that tool is that it does not require nearly as much data as would be needed to do like a classical life cycle analysis, which is a really long and complex process. Because what we did is that we used our experience and we used the analysis of the pilot lines themselves to kind of keep the most important factors and to identify the ones which presumably had less impacts on the results to filter them out in order to make the process more approachable. Of course, this comes at the cost of the precision of the end results. However, once again, it was about looking at the best compromise between usability and precision. So regarding the repair tool, as I previously said, it's based on the same infrastructure as the environmental assessment, but it was specifically targeting repair scenarios. So it was about really measuring the benefits of repair at component level. So usually the most used case was repair versus replacement, but there were also some larger cases with certain pilot plans where we studied some actually retrofitting use cases, which include repair of a number of different pieces, along with also a change in the monitoring and control in electrical installations. And so the goal here is to provide quantitative estimations on both environmental impact and cost revenues. So the results more or less look like this, as you can see. So by comparing different scenarios and also taking into account among different factors, also the avoidance of emissions, which you can see there. It's the part that goes below zero. Which is highlighting the fact that when you repair a piece, you're avoiding the manufacturing of a new piece, which comes out as a negative emission and the final result. Then the last tool is the waste management tool. So as I was mentioning, this is a high-level tool. This is not about quantification. This is more about decision. So this is about decision enablement for sure. But here for waste management, decision enablement, in our opinion, did not come so much through quantification. It came more from a context analysis. So for example, if you're producing wood waste and you're based in France, then what's going to happen? Depending on the quantity that you produce, then this waste is going to fall under this or that piece of legislation specifically. And also by analyzing the existing waste management and recycling structures, you can find that the best practices are this or that within the country. And so based on that information, for a range of different material flows and a range of different countries, we were able to tell the pilot lines what they must do in the different situations, what the best practices look like, and also to provide some recommendations of low-hanging fruits, by which I mean that sometimes it's better we pointed out for them, trying to nudge them forward. We pointed out for them that sometimes the best part is not only to stick to your legal obligations. It can actually be advantageous to go a bit forward. Just to take a very simple, concrete example, when you generate a mixed flow of waste, in some cases, it can be worth the effort to actually try to sort them by specific flow, because at the end you're gonna save some costs on the recycling cost afterwards, compared to a basic scenario where you just keep it mixed and send them to one general waste management company. So this is what the waste management tool was about. So no calculation here, more a study of the environments of the different countries concerned, for the different waste flows concerned, regarding regular obligations on one hand and existing best practices on the other hand. So this is very simply what the sample output of the end-of-life management tool looks like. So this is a small part regarding metals especially. So you can see there that, for example, for the context of France, most of the obligations are actually similar, because most of these flow depend on one same liquid. However, there is a difference between recommended practices to minimize cost and compulsory practices to just comply with legal requirements. Here you have a very small sample of the results from pilot tests. I'm sorry, because our work was about enabling decision making. We didn't go out in the field so much, and so I don't have all those fancy industrial photos to provide. I would have liked that. So anyway, but hopefully these little Excel charts have consequences afterwards on the fancy pictures. So that's my consolation. So anyway, here we've compared the results you can see here. For instance, on the top is a comparison between an increase of productivity by 10% versus I think it was a repair scenario on the second side. And what you can see is that the productivity increase actually has better environmental yields. than the repair. Therefore, this comes as an illustration of a concrete choice that a decision maker will have to face, saying, okay, I have this lump of money, and then what do I use it for? What will generate the most impact? Even for practices which are tough to directly compare with each other. The scenario 3 is about retrofitting. So retrofitting, meaning replacement of several major parts in a production line, compared to an overall replacement of the equipment. So this comes to illustrate that at some point repair is nice and part replacement is nice. However, at some point, the added value of doing this when you start having a large part of your equipment which needs to undergo this process, then the environmental benefits compared to an overall replacement becomes negligible at some point. And finally, this is a sample result for one of the pilot lines. So the pilot tests of those environmental assessment and repair tools allow to increase the amount of raw materials to recycles, to reduce the amount of raw materials consumed when you need a product. It also allowed, for example, to quantify the economies in terms of greenhouse gas emissions in a scenario of repairing 10% of the components. Just 10% of the components actually compensates a very huge part of the overall footprint of the maintenance scenario. And also we calculated the impact of so this was for the wood mill equipment with the Millennium pilot line. We calculated the impacts of treating the wood scraps to produce a particle board panel, therefore enabling a recycling of the scrap material instead of just wastage. All right, that was it for the overview of the work that DSS Plus produced within this project. Thank you very much for your attention.
Thank you, Maurice. Okay, maybe I'll go for the first question. So, yeah, you mentioned our tools. So, are they like one tool fits all, or it has to be like specific for industry, or how is it?
This is the I guess this is the $1 million question. So I would say at the moment there is no one size fits all tool, and that's why it was so interesting to work on this, because this is an attempt to make a partial one size fits all tool, right? But this doesn't exist at the moment. Why? Because environmental impact is very equipment dependent. It's very case by case dependent. So two companies doing the same thing can have completely different environmental impacts based on the equipment they use, the level of lubrication of the tools that they have, and even like the energy they use for heating themselves in winter. So obviously things can vary a lot depending on a large number of factors. However, I mean the analysis factors are the same today, but we're not yet at the stage that we can, for instance, predict for an industry at large what decision would be best and what other. It's a very individual based decision. However, my personal belief is that this is in part because of the fact that sustainability is still a topic of relatively low maturity in large industries. And because of that, as long as time passes, we're going to produce more and more analysis. We're going to produce more and more data points, right, to this overall equation. And we hope that at some point we can start drawing trends. But at the moment, we cannot. What we can do is that kind of work. That kind of work is preparing the overall exhaustive analysis framework tool and then trying to simplify it based on the specific characteristics of the specific industry. Right, so trying to filter out the factors that are less impactful in order to make the tool more generalistic, more adaptable, and yeah, just more fit for a day-to-day use. That way you don't need like a full-time scientist to actually use it. We've been doing this here with the Leveler project. We've been trying to apply this methodology to large industrial lines. On the other hand, we also have programs where we're trying to do this for SMEs. We have some some programs which are about supporting the circularity of SMEs, especially in Switzerland, and where we're trying to kind of compact and streamline all these different tools, not only the LCA, actually, like contribution analysis and so on, to actually bring them to their scale and to a level where they can actually use it without having to expend an unreasonable amount of resources for it.
Okay, maybe a follow-up question. So, yeah, thanks for answering that. In terms of the acceptance of these kind of tools by the industry, because for sure they will need to have a lot of data, a lot of information to provide you. So, in considering these challenges, so do you see them accepting these kind of tools to start using to assess? And maybe from my experience from the level up, or you're also a technology partner.
I would say the acceptance depends a lot on the level of maturity of the company and the decision makers, of course. And while it's true that at the moment it's very variable, what we can say for sure is that things are evolving in the right direction, and they're doing so rather fast. You know, like 20 years ago, for today, most large companies are doing like ESG and sustainability reportings, which they were absolutely not doing 20 years ago, right? However, today's challenge, now companies are getting pretty good at setting sustainability targets, right? But now the main problem is that sometimes, because they're not too literate with that field of sustainability, sometimes the target they set are unrealistic, and so they create problems for themselves. And we've been supporting, I don't know what number of companies which are actually struggling to either select the best actions to reach their sustainability targets, or just reaching them at all, because 5 years down the line, it turns out that it was actually way too ambitious and not very realistic. And so they face a PR problem. So I would say that to answer the question, I would say that the acceptance of that kind of measure is rising, but we're still not at the stage, and I don't think we will ever be at the stage where most companies are ready to launch full-scale life cycle analyses, their whole processes, and especially if you want to do that, with a high degree of precision, then you need to do a whole analysis all over again for each of your use cases. This is not very acceptable from a practical point of view. So that's I think the added value of trying to create kind of polyvalent tools that can apply to multiple situations. Like here, of course, once again, it's at the expense of a part of the precision of the results. But I think overall, in terms of impact of the industry and impacts on the sustainability at large of the industry, it's a worthy effort.
Okay, thank you. Yeah, Martin.
Thank you. Boris, you mentioned the problem of availability of data at the start to as, of course, a resource to be able to do your analysis and provide some meaningful output back to the final user or a company or whatever it may be. Is there a minimum set of kind of requirements that you have when you approach somebody to be able to make sure that you are going to be able to provide something productive for them after a short visibility study of, let's say, a couple of days or is it possible to judge in advance whether this service is going to be useful for a specific entity or not?
I would say there is at the moment there is no kind of minimum list of information applicable to most of the different use cases. I would say that what exists currently is the maximum amount of information that you submit to everyone. You submit it to your client, and then you get back about half of it. And then you need to work with them to try and find or estimate the lacking data. And at the same time, while you get to know the activity, the specifics of the company or the product that you're assessing. As you get to know it better, then you start to, if you have enough insight and experience in that kind of exercise, you start being able to say, okay, this factor, we don't have it, but it's not a problem because it's not going to have a big impact on the bottom line, on the final result. But so far, what we have found is that it's very case by case. So of course, there's a few, like, I can say that there's a few large field factors such as material production, energy consumption. But honestly, it's not practical to say this because material production, well, there's many different things, right? It's not one factor. It's actually a combination of several factors, sometimes hundreds. And so, yeah, you never know. That's kind of the fun part, actually, with that kind of quantification. You never know what's going to be the one thing that kind of tips the equation over. And sometimes it can be quite surprising, you know, like it can be like a little additive in the product, which turns out to have an absolutely massive impact, which outweighs most of the rest, and you didn't really expect it. So I would say, no, there's not really today. That's exactly creating a simplified methodology for quantifying environmental impacts for the purpose of the use of executives in large and small companies. This is exactly what we're trying to do, right? But it's not done yet. It's not done yet, so we do not yet have this common base denominator. Hopefully, we can, get closer to it as long as we progress.
Thank you.
Okay, thank you, Boris. Thank you very much.
Thanks, everyone.
Okay, next in line is Jari. Yeah, he's a researcher at Tampere University and ready for retirement in about a year now from now. So he's excited. So he holds a doctoral degree in technology, passion and focus on the profitability management, and he observes things differently maybe through the lens of accounting. Jari, please.
Thank you, and good morning, everybody. We are talking about profitability and digitalization in this presentation, and content will be following. I will shortly explain the role of Tampere University Level Up project, and then a few words about digitalization, and then the main conclusions. What is connection between these two issues? And our role in this project has been following. It is so that rapid development of technology drives diversification in the supply. And this diversification means more options available. And as beautiful as it is also challenging because those business people, they are totally lost. They don't know which one to choose. And in business, profitability is some kind of driving force. And if you are able to help them to find out what kind of profitability impact this technology will offer, then it is much easier to make those decisions. And we have been preparing that kind of information in this Level Up project. And somehow we may say so that we have analyzed part of that work done in Level Up from economical perspective. And this definition is made by accounting person. What is digitalization? It is simplifying complex phenomena into zeros and ones. And it happens when you are able to put a lot of those, huge amount of those zeros and ones there. For example, at the moment, new car has about 1,400 chips, and one chip may have 50 billion transistors. And that's why it is possible to cover so complex phenomena with these digital systems. Zeros and ones are not important for business, but this simplicity means cost effectiveness. It means ease to use. Of course, easiness is always relative subject. And amount of capacity has increased a lot when we talk about the data amount, for example, and data calculations. And also it has meant new application areas where you have not been able to use this kind of systems earlier. And maybe the key thing here is data processing. And those yellow areas, I think so that digitalization has made greatest impact and greatest improvement. Data collections with those sensors, I think so that in every case, pilot case in Level Up, sensors were installed. Also, distribution based on open architecture is key issue there. And also analysis and interpretation is now easier with artificial intelligence systems and machine learning. And most of the benefits we can get are based on more developed data processing. We have developed this framework to make it easier to analyze changes taking place within companies. And there are huge amount of arrows, and all the interconnections are not described here. But there are activities are there key elements in this framework and interconnections with those activities. For example, when we start from goals and we get certain kind of actuals as a result, it will happen through planning and implementation with support of monitoring and controlling. That's the way to read this framework. And also this box here at the bottom, it combines activities, resources, and capacity. And capacity is also important issue in this framework. Success evaluation takes place in the form of profitability. And of course, earlier presentation was talking about sustainability and things like that. Profitability is another perspective. What makes profitability special perspective is that it's able to measure apples and bananas and compare those ones with each others. That's the main reason why profitability is important perspective. And with ROA model, it's possible to include revenues, costs, and assets. Assets are needed also. Typically, they are not so easily included. And in data processing, there are a lot of changes happening in data collections, 24 hours, 7 days in a week, more data, new application areas, and so on. Distribution availability is bigger. Outsourcing is great option to solve shortage of professional challenges. And analysis and interpretation, learning new capabilities or capacities, and important question there is who is learning. Also, machine is learning nowadays, not only people, and it is great that more capacity is available there. And utilization, for example, machine vision system in quality control, payback time was very short there because it was very good solution there. We divide activities here into two categories. Main activity, for example, Isocon is producing plastic profiles. Producing those plastic profiles is main function, and all the other functions in company are support activities. And main function creates revenues. Support activities don't create revenues, but they are needed. And in this model, we have used modified overall equipment efficiency model. And important modification there is that there is planned category and unplanned category in every capacity loss category. And unplanned is very dangerous for profitability. We are not prepared. That's why it is so critical. And to conclude, I have strong intuition that there is huge potential in support activities to get higher profitability in the future. Less losses because plans are better than ever. Less deviation between actuals and plans. More demanding plans, less planned losses. More capacity, meaning more resources because we are able to outsource and also automate. More capable resources, learning will take place there in our heads and also in machines. Okay, thank you. Any questions or comments?
But okay, maybe I go fast. So yeah, thank you for the presentation. Regarding the use cases that you worked, and the profitability analysis that you have done on these use cases, what are the main results coming out of this?
Main results from Isocon and Tosulin is that it really makes sense to repair old machine, extend the life of old machine when you are modernizing it. Why it is so profitable is that you need less assets. You don't have to buy new machine and invest a lot of money there. When you repair and modernize, you will spend less money, and it means that assets turnover ratio will be very high because modernization makes machine almost as effective as new one.
Okay, so we have a vote for repair than replacement. So thank you.
Yeah,
thank you.
Thank you.
Thank you. Okay, next in line is, so we are going to discuss the success stories of the use cases of Level Up. So we'll start with Julian from Konica. He will talk about the ESMA use case. So Julian has a master's degree in industrial engineering. He started at Fagor Arrasate in the R&D department, later moved to Arrasate's R&D unit called Konica. So he specialized in the field of machine and of process optimization, data analysis, and digitalization. So he has been working and also responsible for the management of national and European funded projects, so including this one. Please, Julian.
Okay, so good morning, everybody, and thank you, Asi, for your introduction. Okay, so the idea of this presentation is to show you mainly how the Level Up project has implemented in the pilot line of ESMA, as well as what was the motivation that we identified at the beginning of the project, what solution we have developed during the project, and what results we have obtained. Okay, but first of all, before starting to present, I also wanted to comment that this pilot line is quite different to the other case, to the other pilot lines, because in this case, we have two beneficiaries. One is Estampaciones Mayo, and the other one is Fagor Arrasate. Precisely, Fagor Arrasate supplies press and stamping system for metal and composite forming, as well as coil cutting and processing lines, and complete installation to manufacture complex sheet metal parts. And here you can see some kind of machines that we supply for automotive, metal, and home appliances sector. On the other side, we have Estampaciones Mayo, or ESMA for now in advance, who makes components for automotive sector, and among its equipment, they have got a lot of presses, forming presses. Most of them supplied by Fagor Arrasate. Here you can see some kind of machines that they have got in the facilities of Pamplona. However, also it's true that the equipment of ESMA is a first level equipment. They also wanted to improve their performance in order to improve or to not to improve, no, sorry, to avoid or to reduce the following issues: low matching downtimes, lack of condition monitoring to know the condition of each component of the machine, as well as how the machine is working. They have also identified some crack problems in the structure of the press that at the beginning of the project they were not controlled, and they also had long and inefficient repair processes. And at the same time, on the Fagor Arrasate side, Fagor Arrasate also identified some improvement fields, and as a machine supplier, they also wanted to improve in some fields. On the one hand, they wanted to improve the features of their machines, and on the other hand, also they wanted to improve the after-sales services, such as digitalization, monitorization, process and machine optimization processes, as well as the repair processes. In this context, Fagor Arrasate and ESMA, they decided to participate in the Level Up project, supplying a pilot line where the objective will be to improve the performance of the machines of ESMA. More precisely, we have focused on a 1,000 transfer press and improve their performance based on the new after-sales services provided by Fagor Arrasate. Okay, so once we have defined what was the definition, what was the objective of the pilot line, the next step has been to develop the different solutions that will allow us to reach these objectives. In ESMA pilot line, we have defined mainly 4 different solutions. Here you can see a diagram which indicates which solution we have developed, which components are part of this solution, and who has been the main developer of each solution. Some of these components has been already presented today here by some project partners. However, now I'm going to give more details for each solution. Okay, the first solution is the condition monitoring solution. Here on the one hand, we have installed some new sensors in the forming line of ESMA, sensors such as accelerometers, oil quality measurement sensor, fiber optic sensor data, and so on. And by means of a new data acquisition system, a new communication infrastructure that have been defined during the project, we have been able to visualize these new signals in a web-based platform. And on the other side, we have also developed a digital twin together with ESI and Fraunhofer that is able to estimate the status of the critical zones of the structure of the press. This remaining useful life signal is a virtual signal, and we think that is very important for us because if we didn't use this kind of solution, we will not be able to know or to monitor this issue using the physical sensors. The second solutions are the predictive maintenance solution, the predictive maintenance models. In this case, the objective of this model has been to estimate the status of the critical components of the press. In the case of the forming presses, we have identified 3 critical components: the bearings and the transmission gears of the kinematic chain of the press, as well as the cracks that are generated in the structure of the press. And once we have defined these critical components, the next step has been to develop these PDM models that are supplied by the data provided by the different new sensors, such as accelerometer, the fiber optic sensor data of pressure transducer, and by means of advanced data analytics and artificial intelligence techniques, they have been able to estimate their status. And not only to estimate their status, but they also visualize the results obtained in these models in a new web-based platform. The next solution has been the multi-level decision support system. These tools improve the decision making capabilities of the end users by means of 3 different components that are the FMECA components developed by Atlantis, the environmental assessment tool components developed by DSS+, and the fusion component developed by Viva. And the last solutions are the in situ repair solutions. In this solution, we have also worked in 2 different lines. On the one side, the University of Brunel has worked on the development of electropulse techniques repair service, repair process, in order to repair the cracks that are generated in the structure of the press. In this case, unfortunately, they have not been able to heal the crack, the usual crack sizes that are identified in the press, that they have 1 millimeter width, but they have been able to heal cracks up to 200 micrometers thick and 1 millimeter depth. Yeah, in these 2 pictures, you can see which was the status of this crack before applying the electropulse technique and after applying the electropulse technique. These all tests have been made in a laboratory level. And on the other hand, IMEN, together with ESI and Thinking Additive, has built an in situ repair cell that in order to be able to offer a new solution to repair the tooth of the broken gears. In this case, yes, we can say that IMEN has successfully repaired a broken tooth of a real component of the press. And here, for example, you can see which was the result after the material deposition and before the final machining of this component. And once we have developed all the solutions, the next step has been to calculate the impact of these solutions on those KPIs that were defined at the beginning of the project. This assessment has been done in 2 different lines. On the one hand, we have done a quantitative assessment, and afterwards we also have done a qualitative assessment. And as for the quantitative assessment, in order to do this comparison, we have taken into account those KPIs that were defined at the beginning of the project. Okay, so the first KPIs family that we have assessed is the production KPIs in this family, let's say, different solutions influence it. And more precisely, the condition monitoring solution, digital twin solution, the 3D models, and the multi-level definition support system in this case have allowed to increase the OEE and the availability indicators of this forming line in 7.7%. This increase has been also generated thanks to the reduction that we have obtained in the machine downtime. And this reduction has been obtained mainly thanks to the process and machine improvement that have been carried out by ESMA and have been proposed by Fagor Lasarte. Regarding the maintenance KPIs, CCS has already showed some results of this solution, but just to say that the detection and the failure remote prediction efficiency has been almost 100%. In this point, it's true that we haven't had any anomalous events in the time interval that we have defined to evaluate these KPIs. And for this reason, we have considered only the true negative events to calculate these KPIs. Regarding the performance KPIs, on the one hand, the condition monitoring platform and the digital remaining useful like digital twin solution has allowed to reduce, if it was possible, to reduce the forming loss of some forming types for forming tools. And this reduction in the forming loss has allowed to increase the theoretical useful lifetime of the structure of the press in 24 years. And on the other hand, also the repair services mainly work by the University of Brunel, Thinking Additive, and IME, have also allowed to reduce the order lead time of the structure of the press and the transmission years. It's true that in the case of the structure of the press, we haven't reached the 8 months KPI objective that was defined at the beginning of the project, because as I have said before, the electropulse technique has not been able to heal the crack sizes that are identified in the press. And because of these reasons, instead of using the electropulse techniques, Brunel has proposed to use more conventional welding techniques. And that's the reason that, and because this same reason, we haven't reached also the objective of the negotiation cost. We haven't reached this objective value that was 200, if I'm not wrong, it was 200 million, thousand euro. Because as I have said, the cost of this conventional welding techniques is expected to be higher than the electropulse techniques. Even so, we will almost achieve a 1 million euros reduction if we decide to repair these critical components instead of replace them. And to finish with the quantitative assessment, the last family that we have assessed has been the environmental KPIs, and here the objective has been to calculate which will be the decrease in terms of energy and in terms of material if we decide to repair the critical components that are the structure of the press and the transmission gears instead of replace them by new ones. And here you can see that if we decide to repair them, we will obtain an energy reduction of 25%, and we will remove all the material needed. And to finish with the presentation, just some comments regarding the qualitative assessment. It has been demonstrated that the tools that have been developed during the project has allowed to improve the KPIs of the forming line of ESMA. And in addition, these tools have made it also possible to to enrich the current after-sales services of Magora Satellite. And what we will do for now on advance? We are committed to promote the production and consumption model proposed by the circular economy, continue researching in those solutions that have not reached the TRL7 level in this project. We'll also implement the solution work in this project in new machines of ESMA, and also we'll try to implement them in new customers. And we will also start creating new tools, solutions, or services in order to minimize the energy and material resources needed of this kind of machines and forming lines. So that was all from my side. Thank you for your attention.
Okay, so we have been discussing the impact of research results on the industry. So I have a question related to it. So thank you, Julian. So you are Fagor Arrasate is a machine builder. You are part of the project. So how do you see the results of the project somehow be implemented into your products? Or maybe I can ask the question in a different way. What kind of solutions that are produced in the project will be interesting for the customers?
Okay, I will say that it depends on the size of the customer and also on the solution that we want to offer. For example, if we consider a large industry or large customers, for example, a car manufacturer customers such as Volkswagen or Seat or Tesla, in this size of companies, they already have their own machine and production improvement teams, as well as complete digital solutions. So in my opinion, it has not sense to offer this kind of software and digital solution to this kind of customers. However, if we consider a medium or small size of companies, I think that the available resources of this kind of companies is less. So it takes more sense to offer this kind of solution to a smaller customers. However, regarding the repair processes, for instance, I think that this kind of solution can be very useful for any kind of customer, from the smaller customer to the larger customer.
Okay, thank you. More questions? Okay, thank you, Julian. Thank you so much. Okay, to continue, we will have another success story of online use case presented by Lucrezia. So she graduated in international relations. She worked in Brazil for some time in European funded projects and as a consultant in sustainability and energy. Currently, she's working in SEM Group Innovation in charge of funding opportunities, and she will be presenting Marlenia use case. Lucrezia.
So thanks a lot. So indeed, I'm here to represent the Marlenia use case. But first of all, I would like to introduce you the company, just to give you an insight. Marlenia is an Italian company based in Lombardia, in the north of Italy, and they are specialized in sustainable buildings because they design and build wooden houses. So all the parts of them, and not only houses for one family, but also multi-familiar houses, as we used to say in Italian. We also have the sector expanded also in the commercial buildings, wooden, and also in redevelopments, more often for, let's say, securing existing buildings from earthquakes, so reinforcing the structure of the existing buildings. What was the situation in Marlenia when Level Up project started? So we have identified three main problems, three main issues. So first of all, you should consider that Marlenia is again, a production company, and there are three main machines. For example, I'm here from SCM. We are one of the producer of these woodworking machines. The complexity of managing these three main machines was a lot. It was very big, let's say, the complexity, especially for planning the production. And what we often experience in companies is that everything is done by the operators. So thanks to the experience of the humans, of the workers in the factory. So also the production process was done mainly manually by the operators. And this, of course, can produce some inefficiency because everything is dependent from the know-how and the experience of the person. The same problem, let's say, the same cause, we also find that in the second part, the maintenance activities and the lack of cyber physical systems. Again, the status of the machine, the maintenance of the machine, how to understand if the machine was working correctly or not, if there was any problem, or if one of the components of the machine was I don't know, having some problems. Everything was done by operators. So again, another time by people. So the human factor is pretty important here. And the third part was the management and disposal of production waste. So at internally, there was no strategy of understanding on how to use, reuse, or how to dispose correctly the waste, the scraps. Actually, Boris described perfectly, of course, the problem in the presentation before. So these are parts of the solution. There are 2 slides that were implemented. So multiple digital solution and tools aimed at enhancing the production line, optimizing the order schedule, improve the maintenance activity, the planning, and of course, minimizing the environmental impact have been developed. So of course, you can see here the partners involved at the end. So the first 3 were developed by TTS. So the first one is the Marlenio, we call it Marlenio platform. Thinking about the first problem that I mentioned, the platform has been developed in order to monitor the production of the 3 main machines that I was telling you about. So monitoring everything, so the system, the data can be export, the machine connectors. Of course, you have a log error section. The second one is not related only to the 3 machine, but was made a step further was made is the plant digital twin. So you don't only monitor the availability of the machine, but you also monitor the availability of the other things you need in a plant, in a factory, forklifts, trucks, everything. How was done? Of course, there was an integration between the data coming from the technical department. So, for example, to understand the timing of cutting a piece of, you should imagine these 3 big machines that are cutting massive panels of wood to do the ceilings, to do the walls. So, of course, from the technical department, there is the import of the timing for cutting, and then, of course, the timing of production of the different machine and the availability of the others. Mm-hmm. So in order to have a very organized production line and to have, of course, everything under control. The third point is the vision system for logistics. This was developed in order to improve the tracking of the single, let's say, panels of the single pieces. Like that, with a QR code, all pieces were checked, of course, first, and then each machine knew where the operators knew where each piece was going in which machine, and of course also the loading and unloading is now made more easy. Going to the other solution developed, the Oikos spindle sensor. So what we have done as SCM together with the other partners, we have decided to take the, let's say, the most important part of our machine, the electrospindle. So the electrospindle is the heart of the Oikos. The Oikos is a 6-axis CNC machine, and there were some sensors installed. Mainly, we have started to monitor both the acceleration and the speed of the electrospindle. After some months of data acquisition, my colleagues were able to create a software, and thanks to the software, now we can monitor the life of the electrospindle. You have thresholds. Unfortunately, there are no pictures here, but you have thresholds. So you have a dashboard, so you can see the thresholds. You can, of course, the data are, for example, of course, acceleration, the speed, the temperature. So you have all the information, and of course, you can realize where and when your electrospindle is about to fail. This, of course, allows you to prevent any stop of the machine, any stop of the production. And of course, you have an alert pop-up that tells you, be careful, something is not going according to the limits that the electrospindle needs to follow. The second one is called a Maestro Connect, and is the real-time monitoring of the machine. The focus was the Oikos machine that, let's say, is the biggest, the most complex machine in the Marlenio production process. With the Maestro Connect platform, again, you have a dashboard and you have a full insight of what's happening in your machine. When I say everything, I mean how you're producing, how much material you're producing, how the production is going, so you can monitor all parameters. The dashboard is really user-friendly, and we say smart machine, smart maintenance, smart analytics, because of course, thanks to the monitoring of all the aspects of your machine, again, you have an insight of what's happening. So if a component is about to fail, you know, and if something happened, you are in direct contact with our service or our customer care. Now in SCM, we have it's called control room. So you as a client send us a message and we try to, we are directly in contact with you. But if, of course, this is if something happens all of a sudden, but of course you can plan your maintenance so you can have your replacements sent directly to you right in time, so your production does not stop at all. The third part is the additive, the sixth part now, the additive manufacturing services. What we have done together with the other partners is to identify what type of component was failing the most in our machine. And in this specific case, we have identified the pinion. The pinion is one part of the machine, is like a part of a chain. And together with the partners, they have tried to, so they reproduce it with additive manufacturing. At this very moment is just lab testing, because as you can imagine, these huge machines, we are doing some more tests to, especially on the hardness of the material, to understand in a real environment how the machine can support the new piece. And the last but not least is the end of life tools, but the Marlenio results were already described by Boris some time ago, some minutes ago, and of course these allowed, the end of tools allowed Marlenio again to better manage the scraps, the wooden scraps, and to understand how to manage them, taking into consideration the Italian, the regional and the Italian regulation, especially for the type of glues and things like that can be in some parts of the wood. And I don't know if there are any comments or questions.
So yeah, it seems the participants are hungry, so we are almost reaching the lunchtime. So I will jump to the one last success story from ISOCON use case presented by Dragon. Yeah, he also PhD in electrical engineering. He's a member of TECOS Slovenian Tool and Die Development Center, and he has been a technical advisor for this project and from ISOCON. He has practical skills in embedded system development, construction, installation, and system management of automated industrial processes. So please, Arjen.
Thank you. Thank you very much, Steve, for the introduction. Hello, everyone. So I will present briefly the ISOCON pilot line success story. If you remember, we are dealing with extrusion. The extrusion line that we have for the use case is around about 15 years old, and we had already a lot of problems there. For example, we couldn't get the data because the PLC was too old. We had limited accuracy. We have frequent extrusion die failures, poor process visibility, really no big, let's say, overview on what is going on in the process, and a lot of things and problems that arise around the line were solved, let's say, consecutively by the machine operators, and they also spent a lot of time dealing with this. And with such line, of course, it's at the time it's really difficult to work. It's about a Friuli machine, extrusion machine from Italian manufacturer, but as you know, like every machine, it wears out after several years of usage. And after adopting the level up solutions, we could increase a lot of things. So we enabled online machine monitoring. We have opened up the data acquisition with the new PLC. We increased that accuracy and productivity. We also lowered the environmental impact and add some new functionalities to the line, like, for example, preventive maintenance through vibration sensor, I will show later. And also we improved the thermal stability. So the thermomechanical behavior, what is going on the extrusion cylinder, on the cooling bath, and then also later to the cutting stage. So we quite made several upgrades, modernizations, like you can see here, temperature, pressure sensors, heaters, also drive units, new PLC, and new, let's say, PID control algorithm for better controlling of the heating zones on the cylinder. Here you can see also on the left the vibration sensor that was used, and also the heaters, additional heaters on the dies, so to improve this thermomechanical behavior and to have a fluent and smooth, let's say, process. On the quality side, we installed vision system together with the partners, in this case with IMEN. And this solution turned out to be very good and also very fruitful. We can distinguish different types of failures, also different colors, gray and white ones, for example. And also when we align this height, for example, we can still improve the accuracy of detection of such failures. And in the past, reflecting to the past, for example, operators need to stay at the line and check if there are any visual problems on the line. Well, on the plastic profiles completely, like little dots, small scratches and similar. But now this was also improved, and we came to another level that let's say we didn't expect to be, so which is a very good sign. And of course, when we gather all this data from the line after modernization, upgrade of the line with several actuators and newly installed sensors, we received a lot of data that we needed to present in a smart and, so let's say, simple way. And here we have, I have presented here a dashboard, how it looks currently. So we can see on different stages, like dosing, motor drive, feeding profile, and also vibration, different, let's say, charts. Also, we can see here on the profile status the result of the vision system results. For example, how many quality A profiles we produce, how many are quality B, the overall counter of all pieces, all those things that currently, previously were not installed on the line, and someone needed to come to the line and check how many parts were produced, and also this is now optimized, and we plan also to further improve with some new, let's say, modifications to better improve it. And also we can check the pressures inside the extrusion die and vibration to see how the die is behaving, because also frequently we can normally there also we expect some failures from time to time to occur. And also, as I said before, in heating zones, we can also control the temperatures, and if they are inside the tolerance range, if something is wrong, we can also see it, and also alarm pops up, and we can really track this. Previously, it was really difficult to have a better overview of the extrusion line. For example, also here control algorithm, and also the thermal behavior control is pretty much improved. And also we added new functionalities, for example, predictive maintenance platform, multi-level DSS tool, together with FMECA and end-of-life tool is already implemented. And also through the dashboard, we can easily acquire it and check. In terms of KPIs, so we have OE and the next three that are very important to calculate it: availability, performance, and quality. Quality, for example, is connected and calculated it through the vision system. Then performance is we calculate it through the speed of the extrusion and the functionality on the exact line. And for the availability, I will show you in the next slides. And probably this OE, because we started the production, is currently low, like 27, but normally when this comes up to the, let's say, constant stable production, it's around about 75%. And also here we have different other KPIs that we calculated and show. For example, what you can see is the modernization cost. It's around about 83 or 85,000 euros, and what I can reflect to the IARIS previous statement, it means that with such amount of money inside this project, we could modernize and upgrade the extrusion line and prolong its useful lifetime, and spare or save around about 180,000 euros, which is really a good result, and we proved that this can be done. And of course, in this case, there is no need to buy a new extrusion machine, but of course, if someone decides to buy a new one, he buys a new one. Okay, I previously told about availability. So what we did when we were calculating these KPIs, we also had in mind the nature of the extrusion production process, and for this we had to also took into consideration the nature at the ISOCON. Which means, okay, for availability to calculate in general, you can use the general equation, which means that you check what is the runtime in hours. So let's say effective productive hours in hours, and you divide it with the planned production time. At ISOCON, normally we have 3 shifts, each is 8 hours, but the normal production let's say productive shift is 7 hours, because 1 hour we need to, for example, for production startup, to check the die, to prepare the material, and to feed in and to start, and to get the first good looking, let's say, profiles with acceptable quality. So this takes around about 1 hour. And on the left side, you can see, for example, from the past several years ago, before the level up started, we had this on a daily basis, like 5 hours, around about 5 hours we needed to spend just on these failures and production startup and so on. And with this, let's say, information, we could calculate the previous availability with this equation here below, and we receive this result 77.9%. And considering, okay, that we have effective, let's say, 7 hours per shift, we can come to the best case scenario, which is 88% calculated below. And from this, of course, you can calculate the availability increase, which is slightly above 10%. but we were still not satisfied with this calculation. And of course, we wanted to, as I said, to take into consideration the nature of the extrusion production line, let's say, process. So we also added here the real-time availability calculation, which reflects the calculation of the availability in real time per shift. So we took this equation at the end, 8 minus downtime divided with 8 and multiplied with 88%, which is the best case availability that is feasible for Isocon to achieve. And with this real-time availability calculation, we can really check at Isocon extrusion line and see what is actually going on with the availability. So inside one sheet, and of course, then you can go to the daily production to show what is on the daily level, monthly level, and so on. So this is one thing how we calculated the availability. So we went, let's say, from easy equations, let's say, to more specific equation, and considering the nature of Isocon extrusion production line production. The second KPI calculation case where we spent a lot of time and went very deep into it was resource efficiency on the energy level, which is calculated via measurement of consumed energy of the extrusion line, and considering also how many kilograms of materials we use to produce those profiles on a monthly level. So the unit here is kilowatt hours per kilogram. And from previous company called Coplas, as you know, which is now a daughter company inside Isocon after takeover, we could retrieve those yearly, let's say, from historical data and information that are available, of course, from the work orders for 2018, 19, 20. We could calculate it. We could calculate those units. We call it units, so energy versus material, on a yearly basis, and we could then calculate here below 0.76 the average value. But of course, here we also considered the entire, let's say, 8 lines that are inside the hole, and for this to be more for this number to be more realistic, we also considered that that 80% of this overall consumption of electricity goes to the lines, but 20% goes to for example, to the water pump system that spreads around the water for cooling each of the extrusion lines. And here we use this 80%, and then of course we have another 80% which reflects the extrusion motor efficiency, which is at around 80%, and it's of course the efficiency of such motors for extrusion, it's not 100%. So we took this into consideration and calculated 0.486 kilowatt hours per kilo. So this is from the, let's say, calculation done for the past 3 years, 2018, 19, and 2020. And then we went ahead to calculate with the new, after refurbishment, the new resource efficiency on the energy side, and we considered at that time the months January to May 2023, so this year, and we precisely measured with energy meter all consumption of all 8 extrusion lines. And then with some calculations, we also checked what is going on the line 1, which is the level up use case extrusion pilot line that we are considering. And we used these equations here, so where we checked the total power consumption of 8 lines, how much material was in kilograms was spent on the line 1 compared to all 8 lines. And then we also introduce here a power ratio, which is a ratio of the extrusion line compared with the line 5, which has the highest connection power. So we wanted to be as precise as possible to calculate this. And then we were able to calculate, for example, from line 2 to 8, what was this energy unit, and we calculated 0.477 kilowatt hours per kilo. And also for the line 1, we could separately then, of course, calculate it. And we did this with the equations below, and we got, for example, 0.473. And then what we did, we could then compare this resource efficiency on the energy side between the lines, let's say 2 and 8, compared to the line 1, and compare it also to the past status as it was. So in case of extrusion line 1, we achieved a 2.67 resource efficiency energy increase compared to the previous status, and the lines, let's say 2 to 8, were at about 1.82. In any case, both scenarios are more than 1%, which is a fairly good result. Okay, if I move on to the last KPI calculation, where we took a more closer look, was again on the power efficiency, resource efficiency, sorry, but on the material side. And we wanted to see from the successfully executed work orders how much good profiles we produced and how much kilogram of material was exactly used in such production. And for this, of course, again, you need a good historical data, and thank God we had them from 2018 and 20. Those are calculated here using those equations that you can see, and we got, for example, a result 9.4 here. Sorry, it's a mistake in the equation. You should divide this with 3. Forgot to add it here, but in any case, those 3 we calculated and we get the result here. What is also interesting here, we used also this factor on this A part of the equation, 0.42, which represents the material share of cost based on the book value and actual value. In other words, this means that more material is taken from the norm that was expected. And this was really great important data that you could retrieve from the historical data from the CoPlus, because they also use this factor on their own calculations. And we also needed to rethink twice and prepare a meaningful equation for those calculations. And then, of course, we calculated then also after refurbishment, also on average, what was going on in the new, let's say, modernized level up extrusion line. And we also took this scrap mass and total used material and calculated this, and we got 3.3%. And then, of course, we could calculate and compare this material efficiency decrease. So what was going on before refurbishment and after refurbishment? And we received around about 6.1%. And really, those equations are really tailor-made for with the knowledge and everything on the process, extrusion process for the Isocon pilot line. And yeah, here the goal was to decrease at least for 5%, but we managed to do it more. And of course, considering all facts and all historical data that were available to us. So that's all from my side. I'd like to thank you and also to apologize Istok, who couldn't come today because he was on an urgent other meeting. So I'm today here, but in any case, in terms of any detailed questions on the extrusion line, you can contact me or him as the same, and we're glad to answer you any questions that you might have now. Thank you.
Thank you, Dragan. Yeah, so very comprehensive presentation, a lot of numbers and equations, so that shows your success story. Thank you, Dragan. I don't know if there are any questions before we go for lunch, or we continue asking questions during the lunch. Okay, thank you so much, and we will come back at 2 o'clock, the same room. Okay, thank you.
Thank you very much. Thank you.
So I think we're all ready to start. This is the final conference workshop, and I'm Dimitris Lokas. I'm a Research Innovation Technical Project Manager for Core Innovation Center. I will be moderating the panel today for this workshop. And with me, I have my colleague, Ms. Yana Sigal, who is Communication Dissemination Project Coordinator for Core Innovation Center. The focus of our workshop today is combining circular economy and Industry 4.0 towards sustainable production. We have a 40-minute agenda here, where we will have all the panelists talk and engage about this topic. We'll try to keep it short and interactive, so you can make a question to our panelists after their presentations. And we have some time also in the end for the online panel to take part in this workshop. So first of all, I want to make a small introduction. Everybody of you has heard about the circular economy. Circular economy is an economic model that aims to eliminate waste and promote continual use and regeneration of resources And it does that by focuses on reducing and reusing the recycling materials and products to keep them in circulation for as long as possible. As you see in the schema there, we have for the circular economy, we have three main pillars. We have design for sustainability, which products are designed with focus on longevity, reparability, and recyclability. We have resource efficiency for, of course, minimizing resource consumption and waste generation as a general goal. And last but not least, we have reverse logistics, which are systems are designed for to facilitate return and recycling of products and materials. Also, as you know, the Industry 4.0, which is the fourth industrial revolution, is characterized using the small schema there for the robots, the control systems, the intelligence and single monitoring tools. So all these processes in the Internet of Things era with artificial intelligence to make the next step. The main pillars of Industry 4.0 in now today, which have the main focus of the sustainable production, are data-driven decision making, which of course tells us that real-time data collection and analysis is optimizing all the processes. The smart manufacturing, of course, as you see the robotics, etc. We have automation and autonomous systems. And last but not least, there's interconnectivity. With all these machine products and services are interconnected through the internet and share information. Now, if we combine the above two, let's say, topics, the circular economy and Industry 4.0, we have reached some mutual goals. Those mutual goals are you see the 8 of those targets, which is, of course, optimize resource management, which as a whole, the Industry 4.0 technologies have helped to reduce waste and enhance resource efficiency, aligning with circular economy principles. We have also predictive maintenance, which is a main focus of Industry 4.0, where IoT and data analytics can be used to predict the machinery and equipment when they will fail, so we can prevent and increase their lifespan, and of course, prevent premature disposal of the old equipment which is working. We have the product lifecycle tracking with IoT sensors integrated in products and to track their usage and condition. Also, we have supply chain optimization, where Industry 4.0 is a real-time visibility to supply chain. We have allowing efficient material sourcing and logistics, which reduce transportation emissions and resource waste. We have customization and local production, and recycling and reuse, which was also before the sustainable production, but right now it's implemented throughout the circular economy cycle and sustainability cycle of the process. We have the circular business models, as we see that companies can shift from traditional linear to more circular time where they can lease services, they can lease products to other companies instead of selling them to optimize their gains. And of course, I left last but not least, the data-driven sustainability metrics, which are the collection of data on environmental impacts, where we have to, this way we can measure through data the carbon footprint throughout the production process and reduce, of course, the carbon footprint, as you see the schema here shows with the green factory on the right side. So in summary, when we're combining the circular economy principles with the Industry 4.0 technologies, we can create a sustainable production ecosystem that minimizes waste, maximizes resource efficiency, and reduce the environmental impact of manufacturing. This integration will not only benefit the environment, but also make a huge cost savings for the industry parties and increase competitiveness for business. So last but not least, I have to tell you some things about our company, Core Innovation Center. We are a group, we are a non-profit research organization. We are currently engaged in Level Up, which is a Horizon 2020 project, but in the near future, we also have major significant Horizon projects you can see below, like AutoTwin, DACAPO, Circular Train, Ambience, and SXIP, which all are around circular economy, Industry 4.0. We do focused predictive maintenance. In the predictive maintenance part, we eliminate downtime production pipelines, We are making a complete maintenance platform product, which if you are interested, you can ask for it, for information about it. And we know beforehand where the next failure will occur in your machinery and prepare you for that to save costs and time. Also, we have the innovation framework where we create comprehensive plans for your digital transformation journey, and we help you achieve your innovation Industry 4 barriers. That's all for me for my presentation, introduction to today's workshop. Now I have to leave the floor to my colleague Yana for the presentation of the panelists. Thank you.
Hi everyone, my name is Yana Sigalu. I work at Core Innovation Center and I am responsible for the dissemination and communication activities of the Level Up project. I'm delighted today to introduce you to our panelists for this session. So first up, we have Michael Pesch. Michael currently is heading the Research and Development Department of Harms and Bende and is responsible for the coordination of all international research projects. He's also a member of the Harms and Bende Leader Group for Operational Management and a member of the Strategic Management Group. So Michael, over to you.
Okay, thanks a lot. Yes, I'm here for representing the Reclaim project and its contribution to sustainability and circular economy. So actually, Reclaim is a project which is a kind of sister project to Level Up. So we are in the same call, targeting on the same let's say targets. Yeah, it's not on. It's better now. I think it's better now.
Yeah.
Yes. Very good. Okay. Yes, I'm representing Reclaim, which is a kind of sister project to Level Up, because we're in the same call from the Commission and targeting on the let's say extension of the lifetime of large industrial equipment. So there's a kind of competition, of course, within these projects, but it's also, or it's even more, let's say, a complementary approach, yeah, because there are slightly different approaches and targets within this project. So in Reclaim, we concentrated very much on industrial needs in terms of supervising and monitoring the behavior of the machines by using sensors, using data, applying digital infrastructure, sensory networks to already existing equipment, and using this information using this data, turning it into information, and trying to find models, physical models, statistical models, in order to monitor the behavior of the machines, and also the degradation of the machines. So degradation monitoring is one, but on the other hand, as I said, it's industry driven. So we are much also in the productivity. So it does not, I mean, of course, we require sustainability, but on the other hand, we also have to concentrate, let's say, that other KPIs as throughput, for example, production rate, waste management, and so on is up on a high level. We had in this project we had 5 demonstrators, and maybe I have the time to illustrate two examples of this. So, for example, we had a company, Gorenje. So Gorenje, maybe you know it. They are producing washing machines, dishwashers. So this white good industry down in Slovenia there. And there was discussion of this within Gorenje and the mother company whether they close this production in Slovenia or not, because the equipment there is very old, more than 15, 20, sometimes 25 years, which are robotic lines, transport systems, welding systems, for example. And at least we can say that Reclaim contributed a little bit in that we have renewed, remanufactured some of those systems, so that the company decided that the production is still there. So I will not say that Reclaim did it all, yeah, but it contributed at least a little bit in this. Another example, we have a partner, Solutech from Turkey. They are producing of textiles. So they have a machine which does not fit probably in this room, which is pretty large. So the input of this machine is cotton, and at the end of the machine you have the textile. And as you can imagine, for example, that the cotton, the base material, comes from the fields and have very different brightness levels. So some of the cotton is very white, sometimes it's more yellow, but at the end you need always the same quality of the textile, which should be white, yeah, because they're kind of textiles for the tables or so. And what they are doing in between, of course, they are applying chemicals there. And in former times, they just put as much chemicals as they wanted to do in order to make it bright. And now we implemented the system. They're measuring the brightness level of the base material of the cotton and applying only that amount of chemicals that is required to have the end product of the textile. So these are two examples which, in my opinion, are quite nice also in terms of the eco-friendly production, not only sustainability but also having a look at the environment. We are also very proud that we have an outcome which is a standardization document. So we managed to standardize to some extent the methodology of reclaim in a document which is released today, and so we hopefully have also a kind of sustainability of the outcome, not only in terms of the technology, what we apply there, but also in terms of having for the public a methodology for the industry that they can follow if they want to have such a digital infrastructure approach with say on top digital support systems and data analytics. Yes.
Thank you, Michael. Are there any questions?
I have one. So
yeah. I can do the Thank you. There you go.
So in terms of them, just this morning we were discussing about the level of results and its relevance to the industry and so on.
Yeah.
So from recurrent projects, I see you have very good profile of the use cases. Mm-hmm. So in terms of using the solutions from the project, so are they going to continue to use it, or they are only limited to the know-how? What is the plan for the use cases in terms of the solutions that were developed in the projects?
Yes, thanks a lot for this question. So this was not you are not the only one who are because outcomes of projects are sometimes pretty complex. So there's always the question how to use it. What our approach was that we tried to find generic approaches for example, degradation modeling of machines. So we did not wait to every pilot and ask, okay, what do you want? We did this environment analysis, but we tried to find say a system, a setup, an architecture that fits to all those requirements. But of course, then you have to tailor those algorithms, interfaces, data collections to the specific needs of the industry and especially in our pilots there. Yeah? So there's this say that kind of basic setup toolbox, yeah, which can be tailored then to the specific needs of the pilots, what we have done within the project. But of course, this also can be done within to a wider range than to the wider public, following what I said, the reclaim methodology, which is now published. But of course, we have the technology providers there who can contribute or providing services on this toolbox if there are partners, if there is an industry that is interested in this. So,
thank you.
Thank you.
Okay, so if there are any questions from our online attendees, please write us in the chat because Michael will need to leave relatively soon. Okay. So moving on to our second speaker. He was already introduced to us earlier today, so I'm not gonna take much of his time. So yes, Chris, the floor is yours.
Thanks, Jana. So yes, it's me again. I was having the first pleasure to have a presentation in the agenda of the morning session. There's this slide that I brought up, and what I did this morning was go through this set of projects that actually deal with circularity. And to illustrate, well, there's different perspectives to circularity. One is the crossing of the product life cycle and the manufacturing systems life cycle. And well, the first example that I highlighted was the DigiPrime project, where we see, some use cases having a multi-sectoral approach in circularity, where, for instance, the batteries from mobility solutions, car batteries, in many cases deserve a second life, or that should have a second life. Perhaps again in mobility solution, but also there's a chance that it's being used in energy systems for buildings. And this shows a very key aspect in the challenge towards circularity. It's bringing different stakeholders together, different technologies together. And this has also been illustrated, I think, in the sessions this morning. But this first example really focuses on really the high-level value network perspective. And since there was a question this morning also about the need for a business case, well, obviously, there is a need for the second life solutions to be, to be economically viable, to be attractive for the users compared to acquiring new systems. And the other set of projects, one of them is ERPF, which is all about, managing the data context or the app context, manufacturing apps that deal with monitoring or that deal with diagnosis of, using the data from historic data from the use of a machine to see how this machine can be optimized for a particular product or for different products in terms of flexibility. And this requires, connections between app providers and manufacturing companies, service providers. So that perspective is also there when we talk about the advanced digitalization of such an ecosystem in terms of the IT, AI providers coming in. And there's quite a set of projects now in the pipeline that have started bringing in the AI and sustainability factor as well. Others focusing then a bit more on the digital twin. So as illustrated also in the presentations of this morning, you can have a lot of big talks about, the big digital twin being the future, or now the metaverse, right? I mean, it's all about maybe big words sometimes, but when it comes down to reality, it's about convincing a company to use a particular technology and to show that, equipping it with sensors has a cost, but it makes sense, even if it's maybe an older machine. Having some investment in people then being acquainted with those technologies, taking some time to see what's the benefit. So there's many projects that are in the pipeline, but really that can learn a lot from what I've also seen in the session just before lunch about the impact analysis in terms of the KPIs, energy efficiency, productivity, material usage. Which again shows how diverse this all is. And maybe concluding, since I'm here as from the European Factories of the Future Research Association, which is the private side to the European Commission in the Made in Europe program, with Factories of Future as a legacy. One of the challenges is to make sense of all that towards the future of the program, and to be able to combine different key technologies with key industrial requirements, with key business cases in call topics together with the Commission that really take part of those challenges and not try to solve all, because solving all requires a lot of projects. And I mean, the thing is really to isolate maybe some of the key challenges and to have them solved, and then to have them shared across the communities also for exploitability, that there's like this ecosystem pushing this forward. So that would be it from my side in terms of an introduction, maybe.
So any questions for Chris? Yeah, sure.
Yeah, Chris, interesting. You mentioned about just multi-sectoral in one of the DigiPrime project. But to me, although it's multi-sectoral, but the application is still the same in terms of energy storage, battery, that sort of thing. So I'm just asking you, what's your view? Is it possible to also build in not just multi-sectoral, but also multi-application in order to maximize the material resources? So my thinking, for example, just thinking aloud, is it possible to take the material originally used for structural application, for example, and then using that waste stream to use in functional application, for example? Okay.
Thanks for the somewhat challenging question, but that's what I'm here for. Well, first of all, getting back to the DigiPrime example, there we're talking about the product being battery still being applied for cloud application in another, it's still another application in terms of the product being the battery, either in mobility and switching to buildings, being used in buildings. So there's a different application, so to say, if you ask me. We can have a beer about that, but clearly, I mean, still batteries are batteries, and they're supposed to deliver energy. And your second example is about, material being there to make sure something holds together, and in another application having more of function in terms of maybe resisting to water or air. Clearly, I mean, there are specific cases where you can imagine that indeed this happens. Just very, very plainly, I mean, this is maybe a trivial example, but I mean, the recovery of, the Tetra mix, which is holding milk, if I'm not mistaken, in recycled manner, they are filling it, they're using it to fill pillows in some cases, or to use that as a filler, So I think there's clear examples, maybe some with less functional requirements or less high level functional requirements. I think in the future, with the need to do more with less material, there will be a need to do something of much high level with the materials that we recover. We were talking about the chips, the shortage of chips. So clearly, anything that we can do to recover such materials and maybe use them in slightly different applications will already be helpful. The material case is also very much a product development case. It's again a big example of product development and marrying the manufacturing systems capabilities with how products are also changing because of circular. And that again, I mean, it's a huge challenge because products will change because of circular, and manufacturing systems will also have to connect to that change, and that involves also materials.
Yeah, I have one, but mainly it's related to the policy. So as you're from EFRA, working on things between research and innovation, what part of several initiatives. So what's next? What should be and what will be the next step in terms of the circular manufacturing?
I could maybe be very ambitious in terms of saying, well, there will be a digital product passport for anything, and we will know exactly what has happened with anything out there, and it will be all connected. I mean, that's the futuristic view, which is, I think, an interesting view to have. But certainly also considering the discussions over lunch, I think it's relevant to still say, what's really required, also in terms of the research and innovation program setting, is to really look at the status in industry now, and to really make sure we don't create a gap. Pushing for the, going to Mars or something, which is interesting, which is good. I think integration will be a key, and I think circularity will be a key issue, and using materials in the best way, managing open strategic autonomy, like it's called now in the policy context, is key. So I think there will be a lot of work in terms of looking what are the developments in key product sectors that are key for Europe, like the energy sector, like what's happening with photovoltaics, the mobility, with the batteries, to really make that connection with those developments, see how these evolve in terms of energy delivery, etc. What manufacturing technologies we need to secure that, and then to bring the circular aspect in, because also there we will have to work with limited resources. I think that's still a key aspect. Another one in all this is the human aspect, where we know that there's demographic evolution that squeezes us a bit in terms of availability of people to manage all this, because somebody will make it happen. So that may also require different policies, but also some technologies to assist humans in controlling all those processes. I tried more or less to make sense of that from different perspectives, because there's different perspectives. Yes.
Thank you.
Any more questions for Chris? Okay, so let's move on to our third speaker for this session, Ignacio Montero. He currently works in the business development unit of IMEN, leading the acquisition of new R&D projects in public calls, as well as promoting R&D business with industrial companies and stakeholders. Ignacio.
Some slides for you. Thank you. So if you can pass to the next. Actually, one thing that we want to share with you today is also our pre-transition in-house as an RTO. So, of course, we're a research center in Spain, and we have a lot of background working on manufacturing and increasing work on working on industry 4.0 topics, and also quite some work on working on sustainability assessment issues for manufacturing, especially for the advanced manufacturing process we're working at IMEN. But this tendency towards circularity has brought us new research lines in the last years, from the digital-oriented research lines that are working on generating new data sources that can help out decision-making for industry in terms of sustainability, and other research lines working on different kinds of inspection that are needed, as we saw this morning, for figure out what to do with components that are undergoing some issues, and disassembly operations using robotics for specific sectors and components, and application of AI in different aspects, including product redesign and oriented towards circularity, for instance. And of course, from the fabrication units perspective, there's a huge focus on sustainability currently, and also being concerned about the reduction of usage of materials for being effective on production. And finally, the growth of the sustainability group towards not only assessing sustainable issues, but also defining new methodologies to understand better how to use circularity in manufacturing, and also integrating safety issues into the design of new products. So it has been a transition for us in the last few years about it. And something that I wanted to share with you as well, so that's the next, is also, we've been seeing this from the morning already. Andreas and Stefano shared a bit the protocols that Level Up used to assess, in this case, machinery. But we have so many, as Chris was saying before, so many different circularity strategies on the table that I normally like to see it this way, like you have short loops, medium long loops, and long loops, depending on whether you're keeping the functionality and of your component or product, or you need to try to recover the material, right? And out of that, of course, recycling is an area where there's going to be, or has been some work in the last few, I would say, decades already, and there's something that is touching manufacturing, but is generally generating new processes, new industries around that. But especially for the short and the medium long loops, I think there's a huge opportunity for the manufacturing sector because it directly addresses expertise from the manufacturing community. So I think that in general, in manufacturing, we really know how to produce, but also we are getting better and better on how to repair stuff, how to remanufacture, how to adapt a product to a new functionality when needed, and also thinking how to redesign our products to be more sustainable and more circular by design. So that is something that opens up way different business models than before. And if you pass to the next, we really think that from my side, we're working quite a lot on the data perspective towards it. So you see in the bottom line, there are steps where you can find yourself probably that you know a lot about. And on the top part of it, there's all these digital technologies that can help us out to do so. So how to efficiently redesign components, how to integrate engineering tools to be optimum in these operations that we saw this morning with simulation. Also how to make good decisions and transmit those decisions to different workers at different levels in organizations. So that is something that we're really moving forward, and that we think that is right the way to move forward new business models for already existing manufacturing industries, and especially for Eichmann. If you go to the next, we want to highlight a couple project that has been mentioned here before today. We take this as a nice continuation, being ourselves coordinators of that in Horizon Europe, of what Level Up was doing for machinery products. Here we're focusing on consumer electronics, we're focusing on aeronautic components, and we're focusing on logistics. But as you may see from the diagram, we're extending also a bit the approach, try to think on full product life cycles, so from design of the component until end of life, and how to put together the digital technologies with the circular strategies and all these long product life cycles, and where to fit the best technologies all around the story and take the maximum profit out of that. And I would highlight on the center of that, because it has been mentioned before, the real important role of digital product passport in the middle of that, so that we can guarantee that information is actually flowing from different stakeholders to actually have access to the real status of components and products to make better decisions. So that's it from my side.
Thank you. Any questions for Ignacio? Yeah, sure. Go ahead.
I have one question. About your Eichmann's involvement so far in the remanufacturing and, of course, for the sustainability of industries. How do you see the transition to the new Horizon projects after 2020? What do you think Eichmann will do more and bring more to the table of the Horizon projects as a coordinator and as a manufacturer, remanufacturer, digital tools supporter, etc.?
Well, in my opinion, in general, I think that, as I was saying before, our role has diversified quite a lot, but I think we find ourselves finding new chances for our production technologies to be adapted to the new challenges, which I think is something that we're finding new challenges every day, and we're finding new applications every day. And I think that a very positive feedback towards that is also the synergies with digital, that we're already there on the table, but we find ourselves really believing on the twin transition hand in hand, because it's really not possible to reach efficiency without digital, and it's not possible to reach quality without the knowledge that we were already having in manufacturing operations. So I think that's going to be a major issue in the upcoming years, and so taking up from Chris' comment before, I really and ask the question, I really think that we need to pace ourselves a bit sometimes with technological results, and I'm really good to see from this last wave of circularity projects what we are going to be getting out of, because landing ideas and understanding which technology is good for which application, I think is going to be very important to understand what we need to continue doing research on in the future.
Thank you very much. Okay, maybe one question. So to follow up what it said. So yeah, there was one discussion this morning with Chris when he said that RTOs should play an important role in terms of bridging the gap with the industry in terms of using of this solution. So how do you foresee this happening? As an example from Ivan.
Yeah, I think that something that we tend to discuss quite a lot about from a technological perspective is technological offer, right? So, and I think that in general, for circularity, we also need to start thinking on how to mobilize demand and how, of course, when you talk to industrial companies, they are a bit reluctant, as you might understand, to modify a product that has been working for them for a long time, and having some uncertainty on who is going to be paying for that or whether there's going to be actual traction on the market for that. And I think that all this social part where we really need to understand that we need people, general society, to actually be interested in bridging closing that gap for us to understand that it's going to be more expensive, that's for sure. And even though we do our efforts to be really efficient, there's going to be still some hurdles to continue working on to reach a point where we are competitive in cost. And it's not only about the cost itself in terms of money, but also how general citizenship would like to invest their money on. And I think that part is something that we tend to forget from the technological perspective, but our end users, every day they think about it. So we need to work out that way as well for us and try to put ourselves on their situation to close the gap.
Thank you.
Thank you, Ignacio. So moving on to the fourth and final speaker for this session, we have Itziar Ikondo. Itziar joined Iveco in 2004. She has held different positions in the departments of innovation, production processes, and since 2022 in ICT and automation research group. So Itziar, the floor is yours.
Thank you. So first, I will start with a small presentation of Iveco. So Iveco is a research center, member of the Basque Research Technology Alliance. We are located in the north of Spain, and it's specialized in advanced manufacturing with a special focus on precision machines and processes and artificial intelligence in manufacturing. So finally, machines, manufacturing, advanced functions, advanced machining, they are our keywords, and this is our strong basis, and we do the research for this sector and for the manufacturing and machine tool companies. So my presentation, my small presentation today will be very focused to the manufacturing and the machines. Regarding the center, as we are very focused on machining, we have relationship with the associations related to manufacturing, like the CIRC, Eusten, EFRA, Factories of Future, ABRA, and so on. And on the right, you can see one of our workshops. So I think it's present and it's visual that we have machines and we research for machines. So just going forward, in this slide, I want to represent the digital transformation, technologies and services towards machine efficiency, extension of life cycle, and avoidance of obsolescence. So beginning with the machines, we are from machines to the smart machine for smart manufacturing, smart services, efficient and sustainable production, and finally to the circular economy. That will be like our roadmap or how we approach the circular economy, beginning with the smart machines. And more related to Level Up project, which finally is protocols and strategies to extend the life cycle of equipment, of large equipment and machines. What we see is that compared to traditional life cycles where we have the initial investment, we see now the life cycle of the machines like a continuous, where in the specific periods of this life cycle, we will invest in applications, in technologies, and in design or so on, but we will increase in those periods putting new applications to the machines. We will increase the value of the assets, and in this way we will be able to extend the life cycle of the machine. So it's important to notice that we are thinking of doing it with these applications based on data, most of them, and also other kind of technologies based on data or perhaps eco-design technologies. So moving forward now, this requires a robust architecture based on data. In Level Up, we have developed a strong architecture to move from the data to specific functionalities and applications. Each of the pilots has customized this overall architecture, but this architecture is very important in Level Up project. In the morning, also Stefano has told us about the importance of monitoring these legacy systems and the problems in data collections and data transfer. And there he also said that the final issue is just the usage of this data. So here we think that we need to go from the asset digitalization to the service digitalization, and we'll represent it in a graphical way. So we've got, let's say here, which are the machine operative excellence. We say that we want to finally improve the health condition, the component or machine level, but finally machine is a system of systems. So we want to improve the health condition, the machine precision, the process performance, and the process qualities. And that requires new capabilities or enhanced capabilities also in our machines, from monitor to control to optimization, and finally to be autonomous. This message or this representation can be also used not only for machines, but for manufacturing systems. But we want to say that with this database applications and services, we want to improve the operational final indicators or factors of the machine, and we need to increase the capabilities of our machines. And that requires an increase in the volume of data, and that's why it's so important to have a strong and robust architecture to support all this monitoring, storage, and finally the applications on that. And finally, some applications, some of them have been commented by my colleagues, and some of them have been developing in Level Up, but just some applications for further discussion. So first of all, embedded data recording of the same data. You have told about these digital product passports that finally we can have the full traceability of the product, and that could be good just for the design, but also for enhance the trust on the circular economy. For example, when we do a repair or manufacturing of a part, just to test or assure that this part is in good conditions, we can have all this information in this product passport. And here, what we will achieve will be that circular economy and trust. For example, another application could be in the product manufacturing, oriented to product quality. And here we've got an example that we can just detect anomalies in production, we can have a pattern of good production, so we can just based on the data be able to detect in process anomalies, but not only for new parts, also for testing after refurbishment or remanufacturing. Another application could be related to the life extension or health status of the component. And that will be, for example, with what we have done in Level Up project regarding the status of the spindles. And finally, we have the machine, we sensorize with some sensors, we have the monitoring system, and we have been able to do some fingerprints to assess the health of the component and be able to predict the status and health of this component. And finally, as the applications that I showed, there will be more, but just to finish my presentation, the optimization of the process and upgrade of components. And this is also something that we have done in Level Up, and that will be just to upgrade components, for example, the nozzles based, the nozzles of the grinding machine based on additive manufacturing, but also to improve the process based on the monitoring of some of the components, and also replacing or just upgrading the properties of all other components of the machine.
So thank you, Icha, very much. So we move to any question for answer to our panelists. You can ask whoever you like, all the people here online. I will check if you have any questions. And just you also, the panelists, can make a question to each other. I have a question for Itya. Itya.
That's okay. I can pose a question. That's fine. Go ahead. Please.
No. You can go ahead first.
Thank you. I'm sorry for going back to another point that we've already spoke about, but it seems to be a sort of an important pain point. This gap that we are always continuing to talk about between the research and the industry. It seems like you have plenty of experience among the three of you in both research and projects such as this one, policies as well, and also industry. Have you ever seen a specific thing that increases the possibility of some outcome of the research be implemented to a final user? Maybe this could be a model of projects. So maybe smaller projects allow for the partners to work closely together, and then this increases the chances of something ending up being used by the industry, or a particular level of innovation. So I was intrigued by the point, I don't know who mentioned it, but we don't need to kind of shoot for the stars and make like super advanced rocket science. Maybe even the smaller steps could be useful for the industry. So my question is, have you noticed any particular beneficial way of doing the research that allows for it to be transferred a bit more easily into industry? And basically, how do we enable, because we continue to have, it seems like we continue to have trouble in this area here. And I'm just wondering what we keep on doing suboptimally and where we could improve to improve this point.
You were pointing at something I said particularly, but please go ahead first.
Mars. Yeah.
Mars, third.
Okay, so I think here every of us can act in its role in the company or in the institution. In our case, I can say that, for example, we are a research center very focused on industry, and we also have collaboration plans with some companies. So we don't have, let's say, one project and say goodbye to the customer. So we try with some of them in having to, just long-term collaboration. And in the applications, for example, that I have shown, our aim is finally to go to a high tier 7 and finally to become these research teams and technologies in exploitable results. Because otherwise, for example, the issue that I showed about just extending the life cycle of the machine. So we have to offer finally technologies that are profitable for the end user and also for the original equipment manufacturer. So these technologies translate into the market. But I think that the issue is just to have really success projects with companies with that finally are willing just to advance and to go to another project and finally to translate these technologies into product and services into the market. But I think that's collaboration long term, but with some time. I mean, it's not long term forever, so they have to materialize into products and services in a reasonable time and being profitable. That's.
Yeah, would you also say that the success stories that you have are kind of smaller steps as opposed to bigger innovations? Is that easier to chew by the industry? So like smaller steps of changing, of modification, because we're all inert to change our ways if something, especially if it's working. So would you say smaller kind of steps of introducing novelty into the process and the technologies is easier or better for them? Or not necessarily?
I think that depending on the TRL, its result is closer to the market. I mean, there are some projects that are more in a less mature state, and for example, we got funding just to when you begin with some technology to learn and to go forward. But there are some others that are in a higher one. So finally, we have this in our case because we are applied research. We have strong focus on the final customer, but also depends sometimes in the technologies you are dealing with.
Right. Thank you.
I think something that is complementary with what Victoria was saying is I think that in general we're really biased by Horizon framework in that sense, but I think starting in a proposal preparation phase with real already ongoing collaboration with some actors and real objectives that are aligned with the goal is very important. And of course, we cannot forget that the actual tool that we have for this in Horizon is having quite large projects that are difficult to manage, that have very different use cases, but at the end of the day, you need to have your autonomy, you need to have, let's say, your small ecosystem with specific focus that, of course, it's aligned with the overall picture, but that you really need to take it down to your specific need, to your customer or potential client a need to be solved, and that is for all the beneficiaries to explore, I mean. And independently on that, of course, agility of frameworks such as Horizon is complicated to handle with market uptake directly after the project because it is not the objective for its original design, and it's going to take some time afterwards. And I think that in general, we need to think on whether we need some more agile tools to close that gap in an easier way for technology providers in general to reach that point. But I think that having a starting point that actually tackles specific issues, and then you can use that to say, okay, I have a use case, a real use case that might be aligned with that. I think it's a very good starting point or a very promising point to continue afterwards and to drive your research towards actually delivering, you know.
Thank you.
I will not be long for sure, but I think there's Horizon Europe, there's a European research context when it is about closing a gap. I can refer to the modernization steps that also Stefano was talking about. There are initiatives on local or regional level where here in Flanders, I happen to know it better because I'm Flemish. There's like factories of the future, even borrowing the name of the European program, where there's audits being organized, done by research and technology organizations, expert audits, not just to say if you're doing bad or good, it's to see in which way you can start modernizing and which are the steps and which maybe, and this comes down to, I mean, whether you would need an ERP system or you have already one, but maybe you would need an MES and stop using spreadsheets, things like that even. Or doing some monitoring and diagnostics on key critical processes in your factory. But for that first, you would need to see which are the key critical processes. Most of the manufacturing companies would know. But this, what I'm talking about here, is outside the context of Horizon Europe. So that's about filling a gap. And it's these companies that then are ready to maybe be part of the, call it Champions League. But that's actually talking bad about who's not in the Champions League. I should not even say that. But it's about those that are capable of saying, well, I have the resources to do some more future, long-term oriented stuff. That's one part of the answer, but maybe we'll have a talk about the second part of the answer with respect to maybe the consortium composition. I think part of the thing is consortium composition. If you have you have manufacturing companies in your consortium, you have manufacturing equipment suppliers in your, if you have like, sometimes you have PLC system providers in a consortium or not, or control system providers, which have the intention maybe to take some of the generated new algorithms or whatever and put it in their product line. I mean, that all has a very big impact on how fast something goes into an offering that can be rolled out to many companies across Europe. And that's very different from one consortium to another, depending on the context.
Thank you.
Thank you. Any more questions? Okay, so I have to tell you we are all very happy to have you here today. I think the discussion was very fruitful and we reached some pretty good insights about the sustainability and about the future. I have here also Chris, who is a part of the future as a member of EFRA. And I want to thank you all again. And we wish you to have a very nice afternoon, and we move on with the closing remarks with Asif now.
Okay. Yeah, the final presentation of the day from the coordinator of the project level of Mr. Roy Mendes. He's a doctor, has a doctoral education on signal and image processing, and was also a postdoc researcher at Fraunhofer, and has been working at IMEM in the smart systems and smart manufacturing unit. Has been involved in several R&D projects, national and also at the European level. So his main research interests include computer vision and real-time signal and image processing. Right, please.
Okay, thank you, Asif. Good afternoon, all. So this is the final session of the conference. I would like to thank the speakers because they already provide a good context and also explain the main core technologies we we're applying in Level Up. So I will try to be quick and just make a quick recap summary of the results of the project. So Level Up is a project from the call DTFOF 06. It was funded together with the Reclaim project, refurbishment and remanufacturing of large industrial equipment. It's an innovation action. We are a quite big consortium with 32 partners. The total budget 17 million and a duration of 4 years. So we started in October 2019. This Sunday will be our last anniversary. So the goals of the project is to evaluate the feasibility to extend the lifetime of large industrial equipment by developing an operational and refurbishment framework. The way to do this is by 3 ways. The first is to improve the dynamic conservative utilization of the equipment. Second one is to improve the maintenance practices. And finally, develop technology to apply remedial actions. So mainly repair and apply technology when something is running our machines. And with this lifetime extension, we expect to have an impact on material resource efficiency and also increase the return of investment. So in the project, we have developed a quite broad number of advanced manufacturing technologies based on mainly on laser applications, 3D printing of metals, and also digital technologies involving digital twins, data analytics, AI, and so on. All these components have been orchestrated by 8 strategies and also 10 protocols that try to make all this technology easy to use for end users. And all these processes, actions, components are linked through a digital thread that tries to keep the information collected in an understandable and interoperable way. And the complete solutions have been applied in 7 pilot lines from different sectors. So the project is really pilot line oriented. So the main results, here is like the big picture of the project where we try to map all the technology that has been developed. At the end is a scalable platform, a service-oriented architecture, quite common in Industry 4.0 projects. And the core of the platform is the data sharing infrastructure we see in the middle and was also explained by Stefano this morning. So as we said, it is really important to collect information, try to measure everything in order to make good decisions. So the purpose of this data sharing infrastructure is at one point collect data mainly from the shop floor and also distribute it among the different services we develop in the project. And the second purpose is also to collect all this data in an organized way and make it interoperable through the use of semantic ontologies. Then starting from the left, we have the pilot lines. So if a new user wants to benefit from a Level Up, they have to start with a modernization protocol. It means the first step is to try to sensorize these obsolete machines and also integrate CPSs and gateways, then make these machines capable to communicate with the other services and mainly with the data sharing infrastructure. Then we have also in the left different retrofitting packages to improving the control of the machines through virtual simulators, for instance, improving the performance, volumetric accuracy, inline inspection methodology packages to have better insights of the quality of the products these machines are producing, but also about the status of the machines. And all this information is shared with the data consuming services that are on this right part, mainly in these 3 blocks. So starting from condition monitoring to analyze the status of the production lines, what are the failures, remaining useful lives, and predicting the problems that can occur. In the engineering and planning block, we have the plant simulators that help us to schedule in a better way the production, and also to simulate different conditions that can help us to implement different corrective actions, saving time. And then, well, at this point, I would say that all these solutions are quite similar to previous projects in Industry 4.0 projects targeting predictive maintenance. So some novelties that Level Up introduces is the decision support, business management, and operation block that is on the top. So here we develop different decision support tools, focusing on three perspectives. The criticality analysis, so what are the main failures that can occur in the machine, what impact they will have. This is the first. Second point is the environmental impact of these decisions we want to take, and also really important, the economic impact. So with these three tools, we can evaluate different scenarios, if it's better to repair a machine or just replace by a new one. It makes sense to install a retrofitting package to improve performance or not. And at the end, this is one of the key points. And then another novel work that we introduced here is this part, reparability services. So here we take advantage of a previous project working in 3D printing of metals like Integrate. The idea here is to provide novel technology that allow us to perform repair, manufacturing actions on components of the machines in a more efficient way. And we combine also simulation of different repair scenarios to select the proper one, path planning, CAP tools to simulate the repair process and estimate also the cost, and novel repair technologies, as I said, 3D printing and also crack healing. Besides this platform, another good result of the project is the circularity protocols. So this was also presented. We have 10 protocols that try to describe actions and processes that can be applied to these machines to facilitate implementation of the technology in a proper way. And we can start from modernization, functional diagnosis, inspection, remanufacturing, repair, and so on. For each protocol, we have created a workflow with all the actions and decision points that have to be addressed. And also all the protocols are related. And then we have the digital thread tool is part of the data sharing infrastructure, and it allows the implementation of these protocols in the digital domain, meaning that we can create here first a workflow of our protocol with the different actions we want to perform. And we keep track of all the activities that are done in the physical world. So we put in common the end users, technical providers, and manufacturers. Each action in each protocol can be done by a different stakeholder, but this tool allows to trace all the data generated during the process and share this information. So the technology has been applied in 7 industrial pilot lines, each with different requirements and business models. First one is Toshuling, machine tooling, in the machine tooling sector. The aim here was to improve an industrial large vertical lathe. We have in the working Marlenio that was already presented. The aim was to upgrade laminated a working center for laminated timber parts. In the automotive sector, we have IPC and CRF that aim to upgrade a pultrusion light for manufacturing rear crash beam. Isocon in the caravaning sector, upgrading an extrusion light for plastic profiles. In the railway industry, we have Lucchini, retrofitting a engine equipment from railway access line. In the automotive sector, Estampaciones Mayo together with Fagor, upgrading a transfer press for automotive parts. And finally, in the aeronautics TRIMEC, implementing a metrology package for a CNC machining center. In the last year, we have demonstrated the technology in the pilots. So for doing the evaluation, we have selected many KPIs that we can group in 5 categories. The first one is useful life extension, performance, reliability and maintenance, finance, and eco-innovation. Here we just draft the overall KPIs we have from the pilots. So life extension is achieved around 5-10 years. Also performance, overall equipment efficiency increases about 10%. We reduce the downtimes. For the finance KPIs, I think we cannot provide an overall figure since each use case is quite different. And also for the eco-innovation, we have demonstrated that the solutions we applied can increase the efficiency of using material. So just some conclusions, finding about this demonstration phase. Also, we did a poll some months ago, we did by Tau, that can help us to understand the benefits of the technology. So the first point is that the digitalization of legacy equipment for diagnosis is very effective, meaning just a simple sensorization of a machine, providing a dashboard with some results to see the status. I think this has been really accepted in the 7 pilot lines in the project. This information is very valuable and can be used for different purposes, condition monitoring and predictive maintenance. The results of predictive maintenance is difficult to evaluate in a single project because the breakdowns usually don't appear, but it's expected to provide good performance in the pilot. We reduced the energy consumption thanks to this monitoring. We can see what are the bottlenecks. Also improve the quality of the pieces, applying, for instance, the metrology of the vision system we developed in the project. Retrofitting packages overall increase efficiency and productivity. Additive manufacturing for repair components is very effective from an economic perspective, also less time consuming than alternatives. And the adoption or participation of the partners in Level Up has raised this aware of eco-friendly practices in the manufacturing sector. Regarding also some challenges, so sustainability is becoming an important feature, a desired feature by manufacturers, also consumers, but is not yet crucial. The technologies developed in the project increase profitability, but in the long term, mainly these digital technologies. So this could be an issue sometimes because SMEs have other priorities. So we have to demonstrate in a clear way that this will be worth. It is difficult to measure profitability and environmental impact of some operations because it's difficult to collect all the data that is needed to have a clear conclusion on that. So it was mentioned also before that digital product passport can support these practices. Another barrier is the adoption of Industry 4.0 by SMEs. This is common to many projects. One topic is the lack of digital skills of operators. One suggestion from the pilots is also in this kind of project, trying to involve the machine operator from the beginning in all the developments we do, so they understand better the technology and also can use it when the project ends. There are also infrastructure gaps, reluctant to share important data. And about the reverse supply chain, so yeah, 3D printing of metals is a very good technology. However, this refurbishment, repair components the use is quite limited, and we need to increase the confidence on this kind of components. And we need to demonstrate that the use of these components can be as good as a new component. And also the lack of life cycle design awareness in this all equipment. So go to sustainable by design products, machines, and so on would be really valuable and will have impact for approaching these circular economy ideas. And okay, this is all from my side, so thank you.
Thank you, Roy. Thank you for summing up the developments, the tools of the project. So that's it for the day, and everything comes to an end. And it was really an intense day with 15 presentations and a lot of discussions covering a lot of topics from modernization to significance of the digitalization, profitability, circularity, standardization, repair versus replacement, and assessment tools, gaps between research and industry. Yeah, more importantly, the success stories of the pilot lines, because that's what we have to achieve at the end of the project. And it has been a long day for most of you, but it was very fruitful for us. So I will end the session by thanking the speakers and the panelists for the talks, insights, and sharing their experiences. We really appreciate your presence here, and also the participants who are physically here and also connected remotely. And of course, everyone who supported this conference in front line or the back line. Thank you so much, and have a safe trip back home. And yeah, last but not least, but for any queries you have regarding the project, please feel free to contact the project coordinator, Roy, or the exploitation and dissemination manager, Nikos. So yeah, we have the website up and running, and we will try to share these presentations and probably some videos of this conference on the YouTube channel. Yeah, that's it for the day, and thank you so much, and have a safe trip back home. Thank you. Bye-bye.